Welcome back to Demystify Sci. I'm Shiloh.
I'm Anastasia.
Today we have a real treat for you. We have the actor and alternative physicist Terrence Howard on the show. Terrence made some waves in the popular physics space in the last, a couple of months ago when he appeared on the Joe Rogan podcast and discussed his unified theory of everything, which pissed off a lot of standard physicists, but we think there's some really interesting stuff going on there, and we wanted to sit down with Terrence and figure out what his model is all about, what fits with what we already understand, and what's left to be developed.
Terrence's ideas are a really good fit for the podcast because the entire goal of Demystify Sci is to be able to go out into the world and to collect the flakes of gold, the needle in the hay, whatever you want to call it, in people's theories so that we can assemble a vision of nature that's more complete than the one that we have right now. And we've had tons of conversations on the podcast about the problems in physics. About 100 years ago, physics abandoned the idea of the mediator, right? We used to have an ether. The ether was the mechanical thing that transmitted light and electricity and gravity even maybe. And then all of a sudden, we lost the ether because of a set of experiments at the turn of the century. And then very, very quickly afterwards, we emerged into this incredibly mathematical conception of nature where it's very immaterial. Like, there isn't a mechanical foundation that we can point to. And Terrence is part of a relatively small group of people that are trying to figure that out. And so this is deeply in line with our show. We thought that he got treated really unfairly. I don't think I've seen anybody who really took the time to understand his ideas. And so
hopefully in this conversation, we're going to be able to translate some of his ideas. He's not a classically trained academic, so a lot of the phrasing that he uses is not familiar to people who are in those fields, but he is talking around a lot of central concepts that we're already familiar with, and so we want to dig into those.
And so we really hope that you enjoy the conversation. It's our first on-location shoot. We've got a guy, Matthew.
First one was Brian Keating.
Our first one, well, that wasn't our house.
This isn't our house either. But,
well, it's somebody's house, and that we are occupying. We've got a guy with us, Matthew, who found us a long time ago and is in our Discord server and happens to live in LA. And so when we found out that we were coming down here, he told us that he could help us out with getting everything set together. And so it has been a much smoother experience because we have Matthew with us.
Matthew can help us with booking too, by the way, in the future. So we're super grateful for him.
Indeed.
Also, we're grateful to our patrons, amazing, amazing patrons. We get together and hang out every week on Sundays. I would love to see you there. It is a good opportunity to chop it up about all of our favorite theories of nature and figure out which ones should come next on this program. If you don't have any money, that's totally cool too. You can support the podcast by liking, reviewing, subscribing. You can share the podcast with somebody who you think would like it. That's probably the best thing you can do. Otherwise, I think you're going to love this conversation, and we'll see you guys next time.
The scientific revolution starts now.
Demystify Sci podcast.
Let us see in the dark.
Yeah, so where do we even start this thing? So I think we start
with a prayer.
All right. I could get into that.
Great heavens, great universe, great spirits, please give us the line towards truth so that we can remain in the I am and the truth be spoken and the truth be the last thing heard.
Word.
Amen.
So I think what I really, really hope to accomplish today is to focus on what it is that is missing from physics and from cosmology, which doesn't necessarily have to be physics. It wasn't physics until about 1920. What's missing that motivates us for looking for different answers? That might be a cool place to begin.
I would think, just throwing it out there, clarity, transparency. I mean, they've done the same thing with physics and science that they've done with music. You know, instead of having just one chart that, you do from right hand and left hand, they have a whole different set of notes for the right hand, a whole different set of notes scaled out for the left hand with 13 spaces in between it, and your mind have to do all this extra work, or pronouncing everything in Latin terms to confuse it, and that's what I love about your show, Demystifying Science. Science is supposed to be the description of the physical and the understanding of physical structures.
Understanding for sure, yeah. The physical structures, I think, is what's missing.
Yes.
Right. If I wanted to put it in one word, in the physics that we learn in the academy and everything that people are doing, there is this descriptive element that involves mathematics, statistical mechanics, field equations. But when you try to ask, what is it that's doing all these dynamics, people look at you like you're crazy. And that seems to have happened at some point, maybe 100 years ago, where people all of a sudden stopped looking for answers to those questions, to the point that it's become completely absurd to even ask those questions.
Don't ask about the fundamentals. That's what Marie, what is her name?
Curry?
Curry.
Okay.
That's what Marie was talking about. She said, let's discuss things, but no one wants to discuss the fundamentals. No one wants to discuss where it came from. No one wants to discuss what happened before the Big Bang. Let's just give us that, like Rupert Sheldrake says, give us that one miracle, and we can explain everything else. But then they need a miracle to explain everything else instead of getting back to the fundamentals. And that's what we were just discussing. Did we make a wrong turn 100 years ago in quantum electrodynamics, where all the renormalization and all of the confusion has come from and all of these imaginary particles, when they left the idea of the ether, which was the quintessence which Mendeleev had in his periodic table when he first laid out the periodic table.
Everybody was on board with it, right? Yeah, everybody was into the ether prior to that moment.
So what happened to the ether?
Right, for thousands of years.
Okay, kind of. So the ether was assumed, but the idea that everybody was into the ether is a little bit tricky on some level, because I think that they were always trying to get away from the idea of there being a physical body that needed to be defined.
How so? Like the point atoms?
So when we're writing this book, and we're trying to write a book about a physical interpretation of the mathematics of quantum mechanics. Do you think that's a fair description?
Sure. Yeah.
And so as part of that, we had this question of, well, when did they stop caring about there being stuff down there? Because it seems like a question that you have to answer in order to be able to motivate somebody to read a book about the fact that there is something physical down there.
And I think that's what Terrence means by fundamentals. He's like, the fundamental of physics should be that there's something doing something.
What's the foundation that all of this is built on?
Right.
But I think that the moment where they were preoccupied by the foundation was so tiny. Like, it's easy to bin it to the turn of the century, because there's the Michelson-Morley experiment, there's the birth of quantum, and quantum is this very fast acceleration in the direction of, we can do math, and that's enough. But even when Newton was writing the Principia, he was still kind of like, we can't really explain this. I can't explain gravity. I can't tell you what it's made out of.
Hypothesis non-fingo.
Hypothesis non-fingo. And so he abandons it and says, somebody else, it's not for the experimental philosopher. The experimental philosopher's job is simply to catalog nature and to find the relationships of nature. And then, that becomes the foundation for calculus. Calculus is incredibly powerful. And so you have this math that now can describe things in motion. Whereas before you only had math that described things that were still or did like very simple things.
But the motion that calculus describes is not, it's not hyperbolic motion. It's still rigid motion, and they use these rigid terms, which is not really defining motion. It's still averaging.
It's like figuring out a mathematical way to deal with continuous mechanics by blocking it up into a piece that you're like, this is small enough that it'll work.
Series of sums,
exactly. Yeah. But so even when they were trying to deal with electricity and magnetism, they were still completely struck by the fact that they couldn't come up with a model for what the atoms were doing, which is why Faraday went with the field. He was a chemist, and his model of the atom was not a like proton and electron model where there was like a hard nucleus. He used there was a mathematician named Boscovich. And so they used Boscovich's atom, which has this point from which force is emanated. It's a mathematical point. It's not an object. And so there's force fields around atoms.
A mathematical point and not an object.
Yeah.
That's confusing.
It is really confusing.
That's an imaginary point that has physical consequences to it. That's the boogeyman.
And that's how they went with it. They were like, this is enough, and we can describe fields and areas of influence.
Well, it's crazy because, like, I was talking with Matthew last night about this, that the word particle, which to most people on the street, when they think of a particle, they think of like a piece of dust or something like that. But when you really push on mathematical physicists, a particle is not a thing. It's actually some sort of dynamic measurement. It has motion inherent in it. So they're talking about an event, essentially, and the event has no actors, which gets really, really confusing. But because they call it a particle, right, the language informs how people think about these things. They feel like it's a problem that's already been solved. So they just treat these events as if they're entities, and they start moving them around and interacting these events with one another. And it's very easily obscured by the type of language that's been adopted to describe these events.
But that's the quantum electrodynamic world. Particle used to be, what did they call it? A
corpuscle?
Corpuscle. When it meant something as a corpuscle, because that was just a part of a wave. And then, but that's what I thought would be the most appealing stuff about the work that we've been doing, is because they've always had that wave-particle duality thing, because a particle is a part of something, whatever the coal means, but it sounds like it's a part of something else. So they could never define the light or beyond it behaving as a wave, but also as a particle. But my work showed that these things by themselves, they look like a particle, but whenever two or more of them are aligned, they become perfect waveforms, and they carry out the waveform. So it defined the wave-particle duality circumstance, and I was like, wow, where's the resistance? Because they don't have a model that describes that. All of their models are either a field, or it's either little bitty dots that they are connecting that they say have no mass to them and things of that nature. They're describing an imaginary world where Porky Pig lives, and they're not describing the reality that we exist in.
It seems to me like it comes down to, how do you possibly have a wave without something waving? Like, wave is essentially a verb. It's what some ensemble of something does. A wave in a stadium is a bunch of people. A wave in the ocean is a bunch of water molecules. Like, to start with waves without acknowledging that something must be waving, you're just going to get lost in your own language at some point. And it's like, what are we even talking about, right? It's like you're starting in the middle of a story and you don't know who the players are.
The story is really functional, though. And I think
it's very technologically
and
functional.
it allows you to talk in the language that mathematicians and engineers require, which is this quantitative description of nature. And I think that there is a natural philosophy tradition of science which seeks to understand these more basic layers and seeks to understand, let's say, the ether. And then there's the scientific engineering side of things, which seeks to just build stuff. And math is what you need to build stuff, because it allows you to parameterize a system, predict it accurately, and then say the system will always behave in this way. And so it makes sense on a functional level why you would do that.
But it has to be the math, there has to be a rigor associated to the math. You cannot have the multitude of contradictions associated to the math. And with what Charlotte was saying, the wave, it has to be in motion, but the term wave sounds like it came from way, something in motion, and how it was on its way to the motion. It wavered along the way, meandered, and I'm not an etymologist, but I'm just looking at the words.
You're right, actually.
But
it's Germanic waver.
Yeah, a wave, it's a way toward something. So it's definitely in motion. So their idea of things not being in motion, them trying to define the universe by static structures that are not in motion.
And they're isolated too. That's the other very bizarre
which
thing.
doesn't exist.
Yeah.
Well, so actually, this is what's really interesting is because field measurements and field descriptions are dynamic.
Right.
They're dynamic by nature. And so what they're actually doing, I think, is they're looking at the motions that their detectors can detect and then saying that the motion is all that there is. They're not going one step farther to ask what is moving. And I think that that's the natural philosophy question. What moves?
What's
That's
being
what you
displaced?
first asked me. What is in motion? And like when I think about putting cold water and hot water next to each other, and the steam that's generated from them interacting, those change of pressure, they're still water. It's still water, but it seems like there is a neutralization or an attempt to balance, and that balance breaks it into a more fluid substance.
Like it gives it structure. It gives it some kind of order.
You get
does
bubbles,
not-
actually.
Yeah,
right?
it's little bubbles. It's bubbles. Everything, the things that we're seeing in motion are the bubbles. These little corpuscles, that are forming their way out. Now, the question is, we see that in the magnetic or the radiative and expansive side. We see the corpuscles, the bubbles out there. But now let's see, are there contractive bubbles? And what does those contractive bubbles look like? And I believe the contractive condensation is what we call what the wave conjugations are. I think those are the things that describe that electric flow that is responsible for the great contraction that they might call dark matter, which they've never been able to define or detect. But the pieces that I've discovered or been granted to see seems to define that electric field or gravitational field in perfection. And then the points where the vortices, where the points, because I'm sure people don't understand when I say that, the points on the edges of these things, when they connect with another side, they predict harmonic nodes. And every harmonic node is where a vortice, a tornado is going to occur, and with consistency. And now that's going to create this draft and draw more of those bubbles together. And some will be pushed out depending on their vitality. If they're closer to the higher pressure condition, if they can stay in the center, they get to a higher pressure. But even at the very center, they get squeezed out and are still forced out. So eventually, every male is going to become female. And I'm saying electricity is always going to become magnetism, and magnetism is going to be converted back into electricity. It's the same substance, just under different motion and pressure
And
conditions.
so before we get into the specifics of electricity and magnetism, which we definitely need to get to, I want to make sure that people understand that what we're talking about here is some very fine-grained substance, right? There's subunits to this ether. They're in some kind of motion, and the particular states of motion of each one of those, what do we want to call them, fibers or little pieces of ether, those motions are responding to the particular pressure conditions in the environment, for lack of a better word. And the result of these pressure conditions, much like the bubbles in water, is that you have higher density in some regions. You have obviously standing wave structures that emerge from that. And so these geometries that we're going to be talking about are the outline or the shape of the voids that result and the high density regions in that. We're going to just assume that there's some sort of either heterogeneous or homogeneous ether, some sort of particle system. I hate that word particle. Fiber system, because for me, fiber implies that it has a structure to it.
Viscous fluid.
Yeah, something. I don't even want to call it a fluid necessarily, but like some sea of fiber of some sort.
Before we get deeper into this, do you guys think that we've sufficiently justified the need for an ether? Like, have we covered? Because like, if you go and you talk to people, they're like, "No, we don't need an ether.
Well,
we have
that's
all this
what
other
we had.
stuff."
I think we should discuss some of the problems associated with quantum electrodynamics that are requiring a greater explanation. The reason why Thunderbolt's project or the electric universe has come out in complete attack against the standard model, based upon the standard model's inability to make proper predictions, in its inability to describe natural phenomenon without having to keep changing their ideas and stretching their model out to where now even the patchwork doesn't work. The renormalization doesn't work. Even the people that were involved in it didn't think it would work. And like Dyson and people like that said, I thought that this hopscotch thing that we put together,
it was going to be a temporary thing. Like we're going to use it as a crutch for a minute.
And then it will find it, and 70 years later, the structure is still standing. I find that absurd. Feynman felt the same thing. So all the people that were involved in it, invested in it, said that it did not satisfy the problem. Even Albert Einstein no longer was able, he never even got any recognition he didn't get a Nobel Prize for his theory of relativity. He got a Nobel Prize for the photoelectric effect, verifying Max Planck's work. He didn't get anything based on the general relativity, but yet there's been a number of Nobel Prizes awarded in the field of general relativity, for people trying to do his work, but it has not led to any verifiable things. They just keep spending more money.
Yeah, I think it's safe to say even people who are at the top of these quantum universes, they seem these castles of quantum understanding, they seem very dissatisfied at the end of the day. You got guys like Feynman saying, this doesn't make sense, and if you think it makes sense, you don't understand it. And that's kind of bizarre. And I think that there are paradoxes that pile up, right? Whether it's entanglement or the wave-particle duality, there's just people all the time point to the quantum world like it's an excuse for why the things don't have to make sense.
The void. And what they did, Rupert Sheldrake mentioned it, but I think Alan Watts said it great. He said they have invented the world. They've created that the world is an artifact, as if it's something that was made and we don't really exist. And the worst thing I think they did when they came up with how planets were coalescing and everything just happened by chance and bombardment, there was now no purpose to existence, and life just happened by accident. So we don't have any responsibility towards anything except, doing whatever we want. And since everything is by chance, there is no purpose.
That's really attractive to a lot of people, unfortunately.
Yes, because they don't want consciousness. They don't want responsibility.
People hate being told, we were just talking about before you came over, people just hate being moralized to, we were talking about that Ozempic drug,
Yes.
And it's like, it's interesting because it does seem to help people get their weight under control, but at the same time, it takes the hard work out of getting your weight under control, which is good for you in a way too.
But what's the consequences?
Yeah, what do you lose? What are you missing out on too?
Like you can take Viagra, you can take Cialis to, deal with a temporary problem, but they're going to ultimately cause greater constriction inside the blood vessels and ultimately will give you a heart attack. So it will lead to greater problems with ED. You have to find another way of dealing with opening up your arteries, like maybe cucumbers, maybe bananas, maybe some olive oil, maybe the natural things that get you into the right places. And therefore you can exercise your manhood without the fears and the threats. But what they've done is they've provided a great deal of Viagra and Cialis into the physics model, that gives everybody these erections, but the erections are not sustainable. And the moment that initial impulse is gone, now they're left with a flat bat and no balls. To hit anything out of the park. You're not going anywhere. So we need to let go of the placebo and let's get to the real cause of it. So the question I really want to ask, I believe that the quantum electrodynamic world is a farce. I believe because it has not produced the models that it said it was supposed to. It has not made the predictions that it was supposed to, and it has not benefited the world the way it was supposed to. It has not simplified the conversation like physics is supposed to. So,
well, simplification is a real monster, though, right? Because you can oversimplify things too, and you can run into sand traps that way.
but that's if you oversimplify in the wrong direction. If you are going in the proper direction, you get back to the source. And that's never a problem, simplifying back to the creator or the space that makes us reflect the creator. That's why we're sitting here, because we want to understand how this great creation came about and what were the dynamics and fundamentals associated with it so we can manipulate it and use it better. That's what we're missing.
And so that's really interesting, because I think that what you said earlier about the project of the quantum world as being a project that creates a universe that doesn't have meaning in it is the only motivation that we have ever been able to come up with for trying to figure out what lies at the bottom.
Who cares about all this? Why should you care about this?
Why should you care about it? And also, yeah, exactly. So the question is why should you care about it? And the answer is you should care about it because if everything is truly mathematical, if the math is at the bottom of the universe, I can imagine nothing except for that being a simulation hypothesis. We live in a video game. We live in some kind of simulation that's programmed by aliens or whatever else. And I think you can choose to believe that. There's some people that will forever, no matter what evidence you put in front of them, no matter what philosophical argument you make, that's their preference. That's the basis for their metaphysics. They want to live in that universe, and you can't convince them out of it because so many of their beliefs are entrenched in that. And other people will say, well, no, I think I live in a universe of physical bodies that come together in these weird ways. And we can talk about the math of the ways that they come together. But we must always remember that we're talking about a thing because we are embodied creatures and we live in an embodied world. And you can't do away with the substance. There is deep meaning and intention in that, in a way that you can't have in a simulation world. And I think that's why it's important.
Well, I feel like the math has now become more like a forensic pathologist that wants to define what has happened or quantify what has happened by taking everything apart and stopping the happening instead of observing things in motion and getting in the flow of everything and moving with the natural forces. They want to stop and observe, and you cannot stop universal flow. And therefore, when you attempt to do that in explaining universal dynamic interaction, what you do is you are taking a nap. Taking another nap, and you wake up and something else has happened, and these breaks don't make sense, and another field jumps up and another field jumps up. String theory was running the world for a while, and then it didn't work. And then they came up with another theory and all of these new particles that they keep inventing to describe and fill up the theory that they have built before, but that has to stop. We've done that enough because we are about to die. Right now, we have to deal with the thiolates and the plastics in our body. That's why science is important, because in 1970, there was a healthy ejaculation had anywhere from 250 to 500 million sperm in it. They did the same test in 2020, a healthy ejaculation had 10 to 15 million sperm in it. So that's a 2.64% drop per year. So you follow that up to that chart out by 1945, there won't be a male left on the planet
2045.
By 2045, there will not be a male left on the planet of any species able to produce sperm because of so that's an extinction event that's happening less than 30 years from now.
PSA, don't carry your cell phones in your front pockets.
Oh, never.
Like, it was really funny.
Never. Don't fry the testes.
Well, I went down this rabbit hole the other day with my brother. I know that this is like a total tangent, but I think it's funny because my brother, he carries 2 cell phones for work and 1 in each front pocket. And I was like, dude, you cannot do that. And he didn't believe me. And so I just went through the literature on PubMed. And it's like paper after paper after paper is like, that shit is frying your balls.
Yeah.
Don't do it.
And it's going to give him testicular cancer, and it's taking his away. He has children yet?
No, he doesn't.
Okay, he may never have any. He needs to. That's why you don't put those ear pods in your ear. You have to, if you're going to use it, you keep the phone on speaker and use the. Even those are a little dangerous, but that's what I attempt to use. But that's why I'm saying there's a necessity, because our world is dying from the fossil fuels and the nuclear waste, and our inability to utilize the universal gifts
Just
in a
food
proper
too,
way.
right?
We're dying.
You go to the grocery store and you pull a thing off the shelf and it's like got 100 chemicals in it. And you're like, what the hell is, I can't even pronounce this stuff. And most of the food is like that. I mean, I don't think it has to just be any one of these things, but I agree with you that something bizarre is happening on the planet right
But
now.
science is the base of those.
Wow.
They did. Where did the dilates come from?
That's
Where did the plastic come from? They were trying to deal with the unrefined
It's
oil.
engineering, though. It's engineering.
That is
It's
engineering.
It's
I think-
engineering, but the scientists get in there. What about all of the fluoride in our food? How did the fluoride get into our toothpaste when we know that fluorine is something that causes, it's an acid. It kills. It causes holes in the teeth. Sorry.
I think it's really important to be generous. There are scientists and their engineering and engineers, and it gets totally confused in the world. Like, there are very few real basic scientists who are just trying to understand how nature works. Most scientists have to pay their bills by contributing to some technology, some product, some sort of food implementation, medicine. Like, these are all engineering. Whenever you take a piece of knowledge and you start to make something for people out of it, this is an engineering endeavor. You're not really trying to just understand nature to understand it. You're trying to take that knowledge and put it towards
Manipulate so you can get some gold.
But there are real, like, Nastia in grad school worked in a lab and they didn't have any engineering. One of your labs was basically just trying to understand how these bacteria used electricity to talk to each other.
And then the other lab was building like brain shunts for rats to be able to
Pure
control their
engineering.
brains. Yeah. So it's like, it's definitely the two sides of it. But I think that it's so interesting what you said earlier about the idea of looking at the whole. Because you can break something up. You can chunk the body of the universe up into smaller and smaller pieces, and then look at that individual thing in a cloud chamber or particle detector or anywhere else, and you'll get some piece of knowledge off of that. It's a mathematical description that you get, or it's some weird interaction that you see, and so you've gained something from it. But the question always remains, what have you learned about the whole? Because the project of science, I think, is to understand the whole. And so as you get smaller and smaller and more abstract, I think you begin to abandon the endeavor of trying to understand everything. And that's where I think mysticism comes in. Because I think that the mystical and the spiritual is, in some ways, the framework for that understanding. Science can't do it. Science can't explain everything. You cannot come up with a theory of everything.
No, but what they've done, they've taken 4% of the universe, and they really do follow and understand that you need an unseen and invisible base, because 96% of their model, of the standard model, is unseen, undetectable, unmeasurable, intangible, and never have been recorded in any way, and that's the dark matter and the dark energy that they use to describe most of. So that most people would call the God, the spirit, the source. So they're still balancing, or like most of us, we live our faith on, okay, 4% of I'm going to do the best I can, but the rest is in God's hands, or in Jesus's hands, or in Moses's hands, or, we are all still part of that spiritual world, and we know that we're rooted in it. And that was the problem with the ether. That became this mystical, etherical, occult-like thing that nobody could touch, intangible. But it really was necessary because even Newton, like you said earlier, Newton recognized that the same way that light, that air was the necessary element and the motion of air in order to propagate sound, that there had to be a propagation, a necessary medium in order to propagate light or electromagnetism. The waveforms that it moved on,
you have two choices. It's either there is a medium or it's magic.
Or it's magic.
That's it. It's like, it's either science or it's not.
They made it magic.
They did. And that's what's so bizarre is that having worked in research for many, many years, there's only one field that's allowed to have magic in it, and it's quantum physics. If you're trying to explain some cancer biology or something, and you introduce some magic thing that's unobservable, that does impossible things, and that doesn't have a physical definition, people laugh you out. Like, you can't talk about that stuff in any field of science except for quantum physics.
And
maybe cosmology.
I think that it goes even one worse, because in science, if you do try to talk about, in medicine, if you try to talk about the spiritual, the ineffable, the field of consciousness or whatever else, you are actually laughed out of the room. Those are probably the lowest.
Even though they're obviously important, like the well-being of the patient, if a person has their friends with them in the hospital.
And the mindset affects their healing.
Right? Obviously. It's so obvious.
And that's the thing that makes it really hard to parse all of this. Because on one hand, we recognize that there is something immaterial that affects the biological realm.
The physical realm.
The physical realm. And so it's easy for us to live with this idea of there being something immaterial, because for as long as humans have been trying to explain stuff, we've had to acknowledge that there's something that's unseen. And so it's really easy to just plug the unseen in at the foundation, because we're like, well, we're working with the weirdest, smallest, most distant pieces of the universe. So obviously there's something weird there, because it doesn't seem to behave the way that we expect it to.
But are they working with the weirdest, smallest pieces of the universe, or are they working with some imaginary thing that they've made up in their mind?
But don't you have to? Just to cut them a little slack, the hypothesis is a thing. Any theory is going to have some foundation on it that you can't see necessarily, right? Look, people had this idea of atoms for thousands of years before, and by atom they just meant corpuscles, little bits of stuff. And sure enough, we can see them now with different spectroscopic means or touching microscopes, stuff like that. AFMs, whatever. But they had to imagine them first. Right? And so there is this imaginary element to the hypothesis.
But that's what I'm saying with science. The imagination, where the spiritual takes place, that's a necessary thing, because you picture our mind as an ocean, still. The first thought that generates there starts as a whirlpool. It's just one little vortice that generates more, and now more, and then next thing you know, it becomes an action. So our consciousness affects the physical world. It starts as a plain and simple, nothing happening, but ultimately it gains energy, and then it passes out through the skull and goes into the world by our functions, because these hands now are working out that little small thought and that vortice, that spiritual imagination. So imagination is the God particle.
Is the swirling honing in on the idea?
Yes, you circle it. It starts as a little bitty thought. You think a little more of it, and then a little more, and then next thing you know, you've got all these other things that's adding to it, and now it becomes a hypothesis. Next thing you know, it becomes an experiment. Now it becomes a thesis and a reality.
And this is why it's so easy for physics to have supernatural actors in it, because we already know from our own lived experience, our interior experience, is that there's something weird that happens when you have a thought, when you have an idea. It doesn't.
I love asking scientists where thoughts come from.
Right? Nobody knows. There's no answer to it. And so we're kind of, in our interior worlds, we're comfortable with the fact that there's weird stuff that happens. And so it's totally reasonable that the people that are studying things that are as impossible to see as the interior life of the mind are having the same sort of frameworks for talking about the physical world. It's just a question of rules. Like, what are the rules by which you have to talk about the physical world? And I think that Shiloh and I have stumbled onto the idea that there's probably something other than just the physical.
Of course.
But if you're doing physics, you can't bring it in. Like, you have to...
It's not physics anymore. It's more like biology at that point. And I often ponder how strange it is that we've decided as a scientific, movement that when we look up at the stars at night, we should only see the physical. In other words, we shouldn't see beings. We shouldn't see biology, right? Like, why is it that the physicists are in charge of cosmology and not the biologists? It seems like a somewhat arbitrary decision to me.
I figured this out this morning.
Hell yeah.
I was reading Schrodinger's What is Life? So he wrote this book trying to take a physics perspective on life. And right in the first chapter, he's like, we can't do biology like we do physics and chemistry because we don't have the math for it. And that's it.
It's too complex.
He's like, it's too complex. Like, you can't put an equation on biology.
Why? Because what happened? They created imaginary numbers instead of staying with trying to work out, all right, what are the real fundamentals? Maybe we've made a mistake along the way and need to readdress our understanding. They're like, no, we'll go down this road. No, I know I need to get my grandmother's house and it should be this way. So I'm going to create an imaginary road and I'm going to go down here and know that my grandmother's going to be here. And then someone else creates another imaginary road. And ultimately,
and nobody's getting to grandma's house.
Nobody's getting to grandma's house because you've gone in the wrong direction. Maybe it's time to stop, take a look at, all right, my surroundings. This is not what I expected. Like, their predictions are not showing up what they expected. So maybe we need to rethink this and go in the opposite direction.
So hard to do once Nobel Prizes are handed out.
Yes, because it makes them...
How do you walk back on that stuff? That's something I haven't figured out in all my time looking at these broken pieces of our foundations, is how in the world do we as a civilization, as a human race, have the humility to be like, well, we fucked up, sorry. And that guy, he was really smart, and we gave him a Nobel Prize, but we're going to have to, have a new way of going about this.
It's their authority that becomes questioned and challenged. Because remember, the presidents, prime ministers, people in the cabinet and parliament, Congress, all of them come from those established universities that have received those Nobel Prizes, that have these accreditations. So when you challenge their fundamentals of what they've established their understanding on, and you're able to prove that it's obsolete or that it's in error, they're afraid to challenge or to bring that to the light, because that the trickle-down effect means that maybe the prime minister shouldn't have the job that he has. Maybe the person at the head of Fermi Lab shouldn't have the job that they have. Maybe the police officer. So our entire civilization begins to crumble. But if our civilization don't crumble, it will die going in the wrong direction. And then you have people that are coming up with reasonable solutions with an enormous amount of proof. Like I said, 100 patents, of geometry that shows a grand universal symmetry.
Efficiency, really.
That explains every aspect of every potential motion and reaction, and has predictions that are reliable and 100% better than the model that exists. Like Chris has told you, I don't know if he's ever shown you, we've put together a weather prediction model, and we've been able to predict every earthquake that's happened over the last 3 years, at least 24 hours before it occurs.
That sounds valuable.
And within a 500-mile radius, we've done that consistently.
We don't have any coming today, do we?
No, okay. But I asked Chris if he wanted, and we can jump on and he can show you that model. But we also have a model where we're able to predict every star on the galactic plane, on the celestial plane, and the ecliptic plane by the linchpin in there, and groups of linchpins. So when they've never been able to do that. A sexton is not able to do that. When you're able to do that, and then you have the pushback or the amount of resistance. It's not even pushback. Now they're like, oh, it's bullshit. Everything he's talking about is bullshit. And it's like, okay, show me where I've made a mistake.
I mean, Chris actually said, can I just read this quote? This is kind of awesome. So this is from Machiavelli from 500 years ago, 1513. Machiavelli, he's this political theorist who's trying to understand how civilizations work, sometimes in the darkest ways. And he writes, there's nothing more difficult to plan, more doubtful of success, more dangerous to manage than the creation of a new system. The innovator has the enmity of all who profit by the preservation of the old system, and only lukewarm defenders by those who would gain by the new system. So you're always up against this behemoth of essentially what amounts to a bureaucracy, right? People who are perfectly happy and comfy with the old way of doing things. I had this buddy in grad school. I would be discussing the things we're discussing today. Physics needs physical mediators, right? And he was a mathematical physicist, and I would just always be trying to explain to him why it was important. And I wasn't as good at it back then as I am now. But at the end of the day, he was always just like, nah, I think that the field equations are fine. I don't see it. It's nice. And he's really good at them, by the way, right? So it's like, well, if I've learned all this, I've taken all these years to master this one way of doing things, I'm not really interested in changing how I'm doing this.
So the last part of that quote, the lukewarm support of those who would benefit from the new system, I think is also telling, because you lose a lot reputationally if you support something that is considered to be crazy or out there or whatever other negative thing you can use to describe it. And so even the people who would prefer to see a new system in place tend to demonstrate outwardly their loyalty to the existing system because it supports them in some way, and they know that they can get a piece of the behemoth by just going along with what the story already is.
Well, if we think about the behemoths and the power structures that exist, they're not as powerful as we consider them to be. The only power they have is the power that we give them by subscribing to their authority. But when you come up with a system that challenges their authority, then that power goes back into the people, and the people, no matter, they may call it lukewarm, but it's a burning hot ember inside of them because they want the freedom that comes with being able to manipulate the periodic table according to your own will. They want the freedom of being able to utilize new forms of energy.
They want to live good lives.
Systems. So they are like, please, like I've heard so many people come up to me and say, no matter what they did and trying to tell you, stop teaching, don't share these things, it's worthless. They're like, no, we need it. I wanted it. I've been looking for this. I'm going to pass this on to my kids. Please keep sharing. Please keep teaching. That's why I did a long wait after the last interview and was a little resistant on doing this because was attacked by so much. But hearing all of those comments, I'm like, no, I'm not doing this for me. I'm like Ezekiel's bones. If he's going to I'm not going to speak God's word. I'm not going to speak God's word. I'm going to stay up here. And it was burning up within him to where he had to go and speak the word. So I'm at this point now where this is why I was put on the planet, and I'm going to share this. And I believe that so much was given to me in this light so that it would be overwhelming evidence. It wasn't like just this one thing, which would have been more than enough as being able to define the electromagnetic field and its interactions. This would have been enough for Da Vinci, for anyone, but to be given that and all of the other things at one point, and I clearly say it did not come from me. I clearly say that I'm not the person that devised this, that I was just following my hands, that I was awakened in this. I believe all of this extra stuff, this is more than walking on water to define the dark matter or what some would call the dark matter, if these wave conjugations describe those. It's more than walking on water to prove that the Platonic solids are averages and approximations, and to have other things that replace the Platonic solids that actually have a better prediction and has a grand unified supersymmetry. That's more than raising the dead to do that, to be able to say, okay, your math is wrong, and this is why it's wrong because of these contradictions. That has never occurred in the history of mankind. This moment right here, where this overwhelming evidence with all the overwhelming proof has been here, so they should recognize what's before them. They should recognize the time that's before them, and if they fail to do so, it just means that they won't be a part of the future, because this is the future. This is happening. This isn't going away. The old system is dying. The standard model is dead. And everyone that's still trying to hide underneath it is just going to be crushed underneath the mounds of dirt that's going to cover it, and they will be erased in history. But those individuals that care about the truth and the wave and the way, those are the ones that are going to be a part of the future. And this stuff right here, like Ed Franco said when he was talking to me about Neil deGrasse, and he respects Neil. He was like, Neil, he said, don't worry about Neil. He's done a good thing. But he said, but you're going to be remembered for this.
I think it's really hard on people, though, because it might be 100 years, 1,000 years before these any of these revolutionary ideas. Like, we have a real good friend who's been on the show a bunch, who has a really beautiful reconception of some fundamental problems with the sun. Shout out to Pierre Marie. And I think it really tortures him that he knows he's right about some of this stuff, but he's never going to get that Nobel Prize. There's no way he ever... And actually, our friend Jim calculated he should probably get something like 8 or 9 Nobel Prizes for all the things he's done. And it's really sad, I think, because people who are outside of this system often, they realize that they're not going to get that, you know...
Why do they want it?
That's a good question. I think because that's the... Look, in science, not talking engineering, but in science, the only thing you get is praise. Right? Everybody's motivated by different stuff, like the love languages or whatever you want to call it. Everybody has something that motivates, pulls them out of bed in the morning. And for a lot of theoreticians, the only thing they have is acknowledgement by their peers, the community, the world being like, that's cool.
What about being able to make an actual difference? And like the unseen spiritual forces, the so-called 4 angels holding back the winds of the earth, or the angel that when he came to help someone and it was like, please tell me your name so that I can go and, and say thank you. And the angel was like, why do you need to know my name when it's a beautiful one? What about just being able to do the work of the Creator and being satisfied with that? Because I was here 1,000 years ago the same way you were, and you'll be here 1,000 years from now, and that inventor will still be here to benefit from the good things. We may not be in this crystallized form, but this energy, it just undulates, goes up and down, and this isn't my first life, and I'm no longer stuck to the idea of being left in here, and maybe that's why the illumination has happened, because I've let go of this, and now I remember the source, and now I am a part of that. That's my motivation now. I don't care.
I think it's whether you identify as yourself, or if yourself is large enough to encompass the time-expanded version of the whole human project and the whole Gaian project and at some scale, the cosmological project of being a being. Like, do you identify with beings and the whole project, or do you just identify with, your sort of mundane existence of getting out of bed and brushing your teeth and, your 401k or whatever?
But even if you identify with the longer term project, there's still the idea that there is a time when the world is ready for whatever concept is on the table. And so if you come up with something that's hundreds of years too early and no one knows about it, and then 200-300 years from now people come back around to it and they rediscover it anew, it can feel really crazy because you devote your entire life to trying to get somewhere, to trying to accomplish some shift in the way that people think about the world. And if you fail at that, I think that can be devastating, even if you have a very cosmic picture of the world, because I mean, who is fully, truly, completely enlightened to not let it get under their skin when everybody that they know and respect is like, you're an idiot? Like,
Well, I'm there. Everybody, I've been called an idiot on so many platforms
but there's so many people who love the ideas that you bring to the table as well, right?
because I know that it's not true. But like the idea of something maybe taking hundreds of years to germinate, nothing happens in the universe unless it's supposed to take place. In order for one thing to take place, every other atom in the universe has to co-sign that taking place, because it will be affected by the change in motion and pressure that has taken place. You put your finger in the ocean, the entire ocean has to register the change of motion and pressure condition from that one finger. So all of that collected together, you put your seed into the ground. And it may take 100 years for the orchard to grow, that your family, your future children will go through and pick from those. We have to stop thinking about the immediacy of this moment and know that we are just part of a moving system. Stop trying to control. You didn't put yourself in the womb. You didn't make your body grow. You trusted the process. We got here. Keep trusting the process. Follow it. And that's what the truth is. And that's where science is at now. They're not trusting the process. They're trusting a formula, they're trusting an idea, and they want to propagate and push their own idea in this mechanistic world instead of allowing the good that is and the truth that's there to shine. And they silence. But people like you two are out here making sure that these obscured little conversations about the creator and about truth are being heard. So thank you guys. You guys came all the way from San Francisco 4 days ago, and have been posted up here collecting my things and working with the things that, Chris and my team has worked with. And you didn't put just an afternoon into it. You guys have really, y'all are sincere and earnest.
Well, the thing that I think we're really committed to, and as we move into looking at your actual model itself here in a little bit, one thing that I saw happen, because I listened to those Rogan interviews that he did, and one thing, and I saw the backlash too, right? Because I feel like first of all, congratulations in the whole world getting either pissed off or excited. That means, like Patti Smith said something, who Patti Smith is? She's this punk rock poet from the 70s. She when she played her first show, she's badass, but when she played her first show, like half the audience walked out, and she said, I took that as a good thing because it means we made people feel something. And they didn't like she made people uncomfortable because she was talking about a lot of the chaos of the world and a lot of the dark underbelly. But I feel like that's actually really important. But the one thing that I think that people got pissed off about is that your language is often not the language that they're comfortable with. So when you use certain phrases, when I was listening to those interviews, I had a sense that I think I know what he's talking about here. But when a physicist who's been steeped in this one linguistic system hears some of those words, their immune system goes off. They're like, wait, that's not what a wave conjugation is, or that's not what a supersymmetry means. And so instead of trying to actually understand what it is that you're getting at, which I think there is some actual profundity, like there's something really deep that we're going to get into about what you're saying with this model that's really important. They get completely distracted because you're not using the same words that they're comfortable with in the same way. And so that was like a huge part of why I wanted to do this interview with you, is so that we could try to translate some of that language so that more people can be brought into this discussion and start to actually use those ideas, maybe even in the mainstream standard space, to actually start thinking about things a little bit differently.
Well, let's not use words. That's the whole point of having the geometry. The geometry is self-explanatory. It's its own proof. You can have an equation that only a couple people will understand that could be fudged. But geometry, even though we see 0.005%, less than 1/2% of the total visual spectrum, that less than 1% can tell you if the symmetry is right, then it's probably right, because that's how we go by biology. Our entire biology is based upon
Structure.
Smell.
Yeah.
If it smells good, then it is good. If it has a genetic coincidence of symmetry, then it's healthy. All of those things. So when you have a grand unified symmetry, whatever idea they had for symmetry before, it wasn't real symmetry. It's like talking to the Son of God.
It's like
They
apples.
can talk
It's an
about-
apples oranges thing,
Yeah,
right?
somebody else, a Pharisee or a Sadducee or a scribe can talk about God, but when the Son of God talks about God, because the Son of God has seen the Creator and is there in front of it, then the words, the definition of from the child of God should be carry more weight than that from the Pharisees or the Sadducees who have misused and misinterpreted the ideas associated with it. Like I said, with symmetry, they've never experienced or observed supersymmetry because the Platonic solids, their fundamentals, the closest things that they have to symmetry, they have a discrete symmetry. You can only put the blocks together, the cubes together to have a supersymmetry. You can only put.
But they're not even talking about structures is the funny thing. When they say supersymmetry, they're talking about being able to swap the force equations for the matter equations.
That's
right?
a bullshit. The force equation doesn't exist because it doesn't really define physical things.
It's not structural.
It's imaginary things. They're basically talking about potential energy. Potential energy isn't measured in motion. Well, potential energy is imaginary energy. It hasn't happened yet. That's like potential children. I'm going to have me some potential children, that's going to do
all my potential money that's in my bank account.
That doesn't exist. That's why with Eric Weinstein, I was telling him, I was like, no, all energy is expressed in motion. All motion is expressed in waves. All waves are curved. Every action has an equal and opposite reaction. The greater the action, the greater the reaction. The greater the reaction, the greater the resistance. The greater resistance, the greater the curvature. Since the universe is built on equanimity, everything has a balance. So there are no straight lines. Therefore, if there's no straight lines, there's no flat planes. If there's no flat planes, then there is no Platonic solids that to make any of these things up. So these, even though they are averages and have worked to give you some idea, they are not accurate. And when someone has something that's a better model that proves what they're saying, that is what should be accepted. So the words of the Son of God should come before the words of a Pharisee.
I wanted to point out one thing Eric got completely wrong when he was interviewing you, was he said that your shapes weren't hyperbolic, and they actually are hyperbolic. And he seemed to kind of like browbeat you out of it in the interview.
He didn't browbeat me out of it. I just looked at him like, okay, do you understand what hyperbolic is?
It's just not the terminal. They don't think structurally is the problem. That's really what it comes down to. It's like if you think entirely in terms of symbolic representations of the abstract, which is what equations are, you're not thinking about structural elements. And so when you're talking about symmetry, you're talking about structural
physical
structure. Like the word physical relates to bodies that have a form to them, right? They have a structure, and the symmetry can be defined structurally in that case, but that's not the way that mathematical physicists think. Or, I mean, Eric's more of a mathematician even than a physicist at the end of it. Actually, most of these people are. I know people are gonna freak out about that, but it's true. I mean, they're comparing abstractions. It's not so much a material structural.
They're not defining the physical universe. They're not describing universal phenomenon. They're not thinking about observable natural phenomenon. They're thinking about things that they hope to occur, but they don't know if they've occurred. And they seem to be desperately trying to hold together and to venerate the gods of old. They want Einstein to be the greatest mind that ever existed. They want Max Planck. They want these individuals, but they don't want the truth.
What is that? What is that need for? Why do we need to deify people like that? Why do we need somebody to worship? Like
because they're going to monetize it.
They're
going to monetize it.
It's just
we also need a main character. Like we need people to believe in that we can point to and say that they have ideas that we like. And especially when they're as long ago as Einstein or Planck or any of the other greats, there's not a real person that's complicated and comes with baggage and has all of the issues that a real live person does. They're figureheads. They stand in for.
And Einstein hated it, by the way. If you read his personal correspondences, he realized he was being turned into a mascot, and they kind of pushed him into a corner at Princeton eventually. And it's really sad, actually.
Yeah, we got the Einstein dog over there. Go say hi to him. Hey,
exactly.
Einstein. That was.
And so it's like there's actually a phenomenon when you build a system where it becomes circularly dependent. Like I was talking to somebody who works at Google, and they were like, if the search stack for Google goes out, we can't rebuild it from the ground up as it is right now because it's built in multiple layers, where the upper layers are referencing the lower layers, and then the lower layer gets rewritten to reference the upper layers. And so the entire thing has evolved as this feed forward and feedback structure. And so if you destroy
Structure in quotes, by the way.
like informational structure or programmatic structure, whatever you want to call it. And so if you destroy the relationships as they are right now, there's no way to recreate Google search from scratch. You'd have to literally go back to the very beginning and start from zero again, because you couldn't rebuild the thing as it is right now.
Will that happen to physics?
And I think that's what we're trying to point to. Is
The death of physics literally happened with the Michelson-Morley experiment. That experiment in itself, and them trying to disprove the ether, or so-called proving the ether, and then 20 years later they actually were able to prove it, but it was not taken seriously because everyone was on Einstein's rubber stamp model by then, because then it allowed a void and you can have all these other monies put into it.
Einstein actually, so there's this really lecture that I always reference. He gave a lecture.
I've got a quote from it right here, actually.
Do you? Read it. Leyden, 1920?
I believe this is from Leyden, but he says, physical objects are not in space, but these objects are spatially extended. In this way, the concept of empty space loses its meaning. But I think what he's trying to get at is that it's a continuum mechanics system, but he's proud because relativity doesn't have to worry about all of that complexity. We can just ignore it and put it off to the side and move on as a result.
And see, that's the problem. You're supposed to be trying to complete a system. That's the desire. It's to get to the truth and to the very center of what's taking place, to the source. You shouldn't be satisfied with getting to the Z of it when all of the things that are going to allow you to have prowess over it is in the A, B's, and C's of it. But everyone wants the Nobel Prize for describing the W's and the M's and all that, because there's no consequence associated with it. But nobody wants to get to the A, B's, and C's of it. And when they see the A, B's, and C's, now their self-referencing system, now it causes their whole, this doesn't work with my model. This doesn't work with the other thing. God, no. Shh.
But can you imagine you call someone to fix your bathroom and they're like, I'm going to have to tear this house down to the studs. Like, they're just like, yeah, we got to rebuild the whole house. You're just like, oh, man, I don't know if I got the budget for that.
But when you tell them, like, hey, you see that foundation crack right there? That's going to cause a falter in all of these things. And your bedroom over there, where your children are at, they're going to die.
Yeah.
That's going to fall over. And then you're like, okay, well, let's rebuild this. If you know that the outcome is there's an immediate danger associated, and the immediate danger is 2045. The immediate danger is the nuclear waste that Japan had to pour into its ocean because it didn't have any place left on land to put it. And now they can't even fish in the seas around Japan. They have to get their fish from Korea now because they were forced to put their nuclear waste in there. And Jeff Yee and I, we just wrote a paper on the neutrino gun that's able to reduce or increase the amount of radioactive decay so that things can get back to a normal state. But I've got another state that makes it much easier that another patent that Chris and I have done, where you can actually refold that nuclear waste back into its natural state in a simple way, just with pressure. Because
Yeah, if
remember,
you guys could demonstrate that, because nuclear is a fantastic option if you can deal with the junk that comes out the other side.
well, think about everything, what happens with radiation. Radiation is about temperature. It gets hotter and hotter, but temperature is what? About a tempo, maintaining a tempo.
Speed.
A particular speed of incidence that causes interaction. So since everything is unfolding through heat and through low pressure, everything unfolds. Nothing unfolds into a high pressure system. Radiation is unfolding in low pressure systems. So why not create a high pressure system to refold it back?
That's what they say is going on in stars, I suppose. That's what fusion is to some extent, right?
And if you could do it,
Can we make some stars?
We can
Yeah.
do it. We can do it. That's what the patents are for, and that's why I'm looking at the resistance like, oh, you guys don't want to be a part of the future. Okay, then we'll build our own breakaway society, and we will use this technology and become the new Atlanteans, or Numerians, because it has happened before. There were particular villages that were still using stones and rocks, and there were other civilizations that had 200,000 years ago that had, greater technology than we have today. And I think that's what's about to take place. I'm done trying to convince the world because the evidence is there.
What's it going to take to build some of these technologies?
Just a group of collectives of people, we're doing it ourselves, starting it with the linchpin and the other applications and just slowly build. And, I'm going to trust that the creator is bringing the proper people to allow this to happen. I'm just going to stay busy doing the work that I'm supposed to be doing. And people are now coming and joining, and the proof is getting out there. The truth is getting out there. We're going to turn a lot of these things into toys so that children can play with. We're writing books. I'm no longer trying to teach the adults you cannot fill a glass that's already full, but the children.
I saw some kid built a nuclear or a fusion reactor in his garage when he was in high school, right? Who was that? I don't remember the guy's name.
He's a nuclear
But,
kid.
it's available. He used parts he bought off Amazon or something. It was just insane.
well, not like Sam Zeloof is
Yeah,
building an
Shout out to Sam.
atomic fab. He basically built a semiconductor fab in his garage, and now they're trying to scale it up into a tabletop fabricator for computer chips that every company could run locally as opposed to having to contract all the way out to Taiwan or whatever, TSMC. But it's like the ability to build something, to have a technology that reflects the ideas is the way that people come around to things. And I think that the success of the physics project in mid-century, if you can call the atom bomb a success, and you can call nuclear power a success, they figured something out, and then they were able to build technology off the back of it. And I think that that's why it went so far to entrenching the model as it was, because the proof is in the pudding. You have a technology that works, and you can't really argue with the technology.
No, but like I said, now we have millions of gallons of pudding. We have the pudding and the patents and all of that stuff that's there. Everything that I speak about has held up. There's not one thing. That was the whole thing with the people are like, yeah, Eric finally put him in his place regarding he didn't, in what way?
What was up with that? I remember him saying, I don't want to talk about the patents.
I don't want to, yeah.
What was
he said, what does the patents have? Because the patents prove that, because the patents have to be granted. In order for them to be granted, they have to be viable. You have to prove them out. Like our neutrino gun patent it's just an application until we're able to go and get an accelerator and point that at some radioactive material and prove it. If once we do that, we have 11 months to do that. And once we're able to do that, then the patent is granted.
Or so you make the application, and then you make the theoretical case, and then the next stage of it is that you build some kind of proof of concept.
And so all of the patents that's been granted is because it's been proven. Like the thing with the linchpin by the International Journal of Aerospace Engineers, peer reviewing that I have invented a new form of flight with a new geometry that has unlimited midair bonding. And
What do you mean unlimited mid-air bonding?
Most things, they've never been able to bond two things in the air.
Like they can dock with each other.
Docking in the air. The linchpins are able to, whether it's 108 of them, or whether it's 4 of them, or whether it's 5, or 54 of them. They're able to bond, and how they're bonding is based upon, they're basically rebuilding the periodic table. And the engines that should be arguing against each other, these vortices, because of their natural angles of incidence, which Chris sent over to you too, Shiloh, some of their interactions, they all continually
They just kind of
work
click
together.
into place.
Yeah, it's like, they're being drawn into their place once they're oriented in the proper arrangement. So for that international journal to do a special thing and put that out there. So for Eric not to want to talk about the patents or those papers and all of that thing, I was like, oh, that's telling. Maybe they don't want the proof out there. Maybe it's because Eric's a sincere guy. Eric, he comes from a really beautiful place. And I think half of what he was trying to do was say, hey, Terrence, I need to warn you, stop teaching. Mm-hmm. Be careful. They'll try and hurt you if you keep doing this. And it's like, dude, you don't know. This will hurt me if I don't do it, because I'm sure I was supposed to do it in a previous time and I didn't do it. And now I'm forced to sit here trying to do this. Now I want to finish whatever job I was given and get this out there. And Eric has the responsibility also of sharing truth.
Well, it's really funny because he comes from a position of being shut down too. I don't know him personally or anything, but from what I've heard him talking about, he seems very, very wounded by something that happened to him inside of the institution as well.
Well, he had his theory of everything, and they attacked it. And one of the things that he was lacking, though, was the models.
The
He did not have structure and model. It was still hypothesis and theory. Mm-hmm. And that's what troubles me, or not, it doesn't trouble me because it's just par for the course. It's happened to everyone that's been in my position, and they talk about being peer reviewed. He's right. I don't have a peer. There are no peers regarding me because there's no one in the history of the annals of time, and I'm not saying this to pump myself up. I'm isolating myself. That have been able to come and challenge the math and the number theory with a reasonable and logical challenge that they've been unable to resolve, that they now are call it the Howard comma, this contradiction with the square root of 2, cubing it and multiplying it by 2 and having the same value in that loop. Eric was like this Howard comma thing, but that they're calling a fixed point. That is a lie. If you turned in a paper as a mathematician trying to get your doctorate and you had this obvious contradiction, this loop there, they would tell you to go start over. But here, all of our math is based on that. Never before has someone come and challenged the Platonic solids.
I think you do have peers, man.
Hold on. No, I'm saying with the Platonic solids, when have somebody come and challenged them and able to prove that they were obsolete and unable to hold up and have a new system that's able to do a better prediction of it? When has that occurred in the last 6,000 years that someone has been able to overturn the apple cart to such an extent with proof and have the platform for it? So no.
Maybe you can explain to people why the Platonic solids are so fundamental to our conception of nature.
Well, Euler's number came off of the tetrahedron and all of those interactions. Pythagorean theorem came off of the cube, a squared plus b squared equals c squared. And that's where that problem of 1 times 1 equaling 1 first showed its head, because if one length was 1 and the other length was 1, well, 1 squared is 1 and 1 squared is 1, then that side was 2, so they could not use, if it's a 1 on either side of the A and the B, they have to turn that into 12 inches or other things because it is, because the multiplication doesn't work out for it when you have the 1 squared and the 1 squared, which both equals 1, then you don't have an answer for it. Do you understand what I'm saying? Well, we'll take the Pythagorean theorem and take each side, A, B, and C. And if A squared plus B squared equals C squared, how do you have, if you have the value of the length A as 1, like if length A is 2, and the length B is 2, then 2 squared is 4, and 2 squared is 4, and now you're able to do the hypotenuse. But if the length of A is 1 and the length of B is 1, how do you solve that?
Well,
how do you get the hypotenuse?
Well, isn't it just the square root of 2?
It's the square root of 2. So what's the square root of 2? What's the square root of 2? If they say it's 1.414213562373095.
You seem like you've looked into this.
Yes, but if you add that together, if you add 1.414213562373095 to 1.414213562373095, you get 2.828427121746190. That is the square root of 8. That right there is the square root of 8, but that also is the square root of 2 cubed, and it's the square root of 2 times 2.
So the last time that I was looking at the square root of 2 thing and the Pythagorean stuff, the way that I thought about it was geometric in nature, right? So if you have a square with that's length side 1. So let's say you have a chessboard, and on the chessboard you only have 4 cubes, right? And so then you have unit side 1, 1 times 1 gives you 1, right? And then if you have a length of 2 on each side, then you do 2 times 2 and you get 4. And so that's
So look at the difference of it. You just did 1 times 1, an area times a length equals an area.
Sure.
But there was no area generated when you said 1 times 1 equals 1.
Well, why? I mean, imagine that this
What's the area of 1 when you had 2 times 2 equaling 4? There was a change, so now you get an area, but when you have the 1 times 1 equaling 1, there's no area generated for the length times the length.
Well, I think that the idea is that it's a unit area, right? So like a square that is 1 by 1 by 1 by 1 on all 4 sides is the unit square. And so as you double the length of the unit square, what you end up getting is you're not getting out a length, you're getting out an area. And so the area quadruples as you double the length of the sides. And so in this sense, in this like 2-dimensional representation of it, it makes sense that like the fact that you get 1 as the area and it doesn't increase is because the 1 is reflective of moving to a new dimension.
A new concept.
But how is it that the 2 creates an area and increases in it, and the 2 is just 1 doubled? And if A is equal to B and B is equal to C, then A is equal to C. Why is 1 given a special relationship when the number 1 is the father of all the other numbers? So if 1 behaves this way, then all of the other numbers should behave that way. Why is 1 giving this special attention? And that's where the identity property, I
see what you're saying.
The problem.
You see what he's saying?
Not yet, because I'm like,
his point is that if you have a square of length 1, the area isn't larger than the length. But if you have a square of length 2, the area is larger than the length. And that is pretty bizarre if you think about it.
Well, no, because we're moving up in dimensions.
No,
it's just for a square, just for a 2-dimensional square.
It still should have an area.
I mean, I don't know what it means.
You don't get an area when 1 times 1 equals 1. And then again, here we go off of the physics. Let's separate math from the physics. We're in action times an action doesn't have a reaction. Oh, we're in the imaginary world. We're in the imaginary world where an action times an action doesn't have a reaction. And so what they'll do is they create this contradiction where, okay, well, 1 times 1 should equal 2 based on the associative and the commutative laws. If A and B are both positive integers, then A should be added to itself as many times as there are units indicated in B. Therefore, if it's 2 times 3, 2 should be added to itself 3 times.
No, hold on. Like, what? This is like, I hear what you're saying. Where you're like, if you're multiplying these two things together, then why don't you get a larger number from the multiplication? But it's like, if I have 1 pen once, I just have one.
It's not just, it's 1 pen times 1 pen.
Yeah, you didn't do 1 pen once. You got 1 pen here, and you've got 1 pen here. That should create an area here. You have this pen 1 times 1 that should have this area, and now this area has no definition because of their square root of 2 issue. And then the square root of 2, if it added up, it would be fine. But because there's a contradiction where the square root of 2 cubed has the same value as the square root of 2 times 2, that's a problem.
Wait, the square root of 2 times the square root of 2 is...
Here, take this. Okay, no,
right.
we go. My wife, you can. I'll call you back, baby. I love my wife. But here, let's do it here. And so you can see. Here.
Okay, perfect.
Boom. Here's 2, and take the square root, 1.414-213-562-373-095. Now I'm going to do times 2 equal 2.828-4271-2174-6190. Now I'm going to divide by 2 equal, I'm back to the square root. Mm-hmm. Now I'm going to hit cube, x to the third. 2.828-4271-2174-6190. Watch this. Divide by 2 equal. I'm going to cube it again. 2.828-4271-2174-6190. I'm going to divide by 2. I'm going to cube it again.
Tim, this feels like a card trick.
It's a loop. So picture this. I'm multiplying 1.414 times 1.414 times 1.414, and I'm saying that's equal to 1.414 times 2.
That's pretty fucking weird.
And then it loops itself back up because of the Pythagorean theorem, because there are no straight lines, and because to multiply means to make more. To increase in number. It does not mean to make less. Multiply and become many was not to become less. It's to become more. So those are the things I'm talking about. And when we were on the show and I'm talking to Eric about it, he said that's a fixed point. I said, no, that's a bullshit point. That's a lie. That shows you that your math is off. Let me show you something else. Let's take the number 1. I'm going to divide it by 2. You know, it's a 5, so I'll times 2. Now, if I try and square it, nothing happens. If I try and do the cube root of it, nothing happens. But now let me take the number 2, and I'll go back. I just went up to the cube root of it.
I think a little bit more towards you, by the way, so people can see it.
Okay, good.
Yeah.
All right, now I'm going to cube root it 33 times. And watch, you're going to generate an entirely new one. This is their math. This is their 1. Now watch, I'm going to divide it by 2, so you know it's the same, 0.05. I'm going to times 2, so we'll be right back there. Now watch when I cube it.
Whoa.
Okay, hold on. No, we're not done. Now we're going to cube it. Is that a cube of 1? No, let's cube it again. It's a 5. Now watch what they're doing. They're going to multiply it by 3. They're not cubing, and they're multiplying by 3. They're multiplying by 3.
That's really interesting.
And then they add a 1 to it. What in the fuck is this? What in the fuck is this whole nother set of 1 that will come up here and watch? I'm going to get it right back to its life. Now we can
Take
the square root of it,
or the cube root.
the cube root of that, and now watch, we're back to the same number. How do you have those separate operations taking place within a calculator? I've just shown you that it's bullshit. Their square root of 2 is bullshit. Their cubing is bullshit. Their values of 1 is bullshit. And here I show them the proper thing, and they get mad about it because it messes up their system of profits and gains. And now how do you argue that and say, oh, well, no, we need to go down this road? That's a false road. That's a false road. This has been programmed into every computer, every calculator. They have deliberately put this in here.
It's probably an artifact of how they're running the calculations. I mean, like, right? Because if you think about it, like, what does it mean to get a cube root of a number, or the natural log of a number, or Euler's number, or anything else? Like, these are...
There's roundings and
there's
stuff.
roundings and there's
It's arbitrary.
It's, I mean, I hate to say
formalized.
arbitrary. It's formalized.
It's made up.
It's formalized.
It's normalized.
Okay, well, so hold on. I think that if we put down the idea that there is a physical relationship that must underlie all of the mathematics, then you can say a mathematics that doesn't go back to some kind of geometric or some kind of physical relationship, ergo must be made up, because what is made up if not corresponding to something you can point to and observe and hold in your hand or whatever else?
What are numbers? Numbers is a part of something
Magic.
to measure quantities. So quantities are a physical thing, whether you're imagining them or not. They're taking place and building structures inside your mind. So they should have place and they should have responsibility to the other laws of the universe. So that's where I'm saying, when you can do this, when you can sit there and show that this, you can't give me no calculation and tell me that I'm going to trust this, because I can show you where this doesn't work. So your math isn't mathing.
Let's, can we take a break? I have to pee really bad.
Okay,
I'm sorry.
and yeah.
I mean, one thing I think that we could really use the back half of this conversation for is to actually lay out your model, because I was personally, and I know a lot of people that we've talked to were really disappointed that you didn't get a chance to actually present the big, like the picture to people, right? You guys, I mean, the conversation quickly went to what was wrong with this or that idea, but we didn't actually see the model in and of itself at any given point in time. So I want to make sure that we save time for that. You had a point, though, before we get there.
Okay, so I think before we took the break, we were talking about the idea that, numbers are abstract representations of something unless they're related to some sort of physical geometry. And we were also talking about the fact that the math of the square root of 2 doesn't totally make sense, because if you take the square root of 2 and you square that, you end up back at 2, but if you multiply it by 2, you don't end up back at 2. And Shiloh and I were talking, and it's like, it's almost as if the unit square, when you multiply 1 by 1 and you get this thing that we also call 1, should be called something different. It should be called like theta or something. And like, it should have a symbol standing for it, because it's an abstract representation of this new, instead of having just length, now you have 2 dimensions of length times width. And so that 1 doesn't represent the same thing as the unit length of the sides. It represents this new emergent quantity that then you can tile to produce larger and larger squares. But the 1 by 1 itself isn't the same as 1. And so if you call it 1, that's where the confusion comes from. Like, it should have a distinct number for it that is set as, like, when you multiply 1 by itself,
it's usually like 1 centimeter squared or something, right?
Sure, that's true. And it is, but because of the fact that the square root of 2, which is the diagonal of that, has this weird property to it, clearly it's representing some kind of different thing, because it should be equal to 2. Everybody on the internet seems very comfortable with this. They're like, it's high school math, you idiots, don't you understand? And I'm like, that's kind of weird.
It's indoctrination. And they're accepting it because it's just been pushed upon them. And to challenge it means to now unpack all number theory. No one wants to do that, because all of the rest of the foundations of math has been built off of this number theory that has faults within it.
So what's the alternative?
The alternative is now, it's because we're attempting to multiply linearly, and we know that nothing in the universe expands linearly. To multiply means to expand, to make more, to increase. So we have to follow universal protocol and multiply volumetrically.
Okay.
And the volumetric that we understand is there are these 6 planes of interaction.
Is there degrees of freedom?
Well, based upon the angles of incidence that occur with the proton and linchpin, with the proton as itself, you end up with 6 planes.
Forward, backward, right, left, up, down.
1, 2, or these individual 6 planes occur from these 4 bubbles meeting. That's the simplest thing that they can come down to, and everyone has accepted that this is the simplest model. But these planes of incidence, they are not accounting for. They're continually trying to multiply as if this is on a flat plane. And that's not how the universe multiplies. That's not how biology multiplies. And we have to think, then we need a new term. If you're going to multiply 1 times 1, you can't call it multiplying if it's going to equal 1. You cannot call that multiplication, because to multiply means to make more. Plain, simple, close the door.
So
Makes sense to me.
the weird aspect of the square roots is consistent. Anytime that you take the square root of anything that isn't the product of two integers, you get the same problem. So if you take the square root of 1.3 and then you multiply the square root of 1.3 by 1.3, you don't get 1.3. Mm-hmm. You get something that's slightly larger than 1.3. And so this is just a problem with trying to multiply things that aren't whose roots are not actually integers. And so there's like a set of numbers that are perfect, where you can do like 2 times 2 is 4, and the square root of 4 is 2, and you multiply that by 2, and you get back to 4. But anything that's irrational, is it an irrational number?
They call it irrational, and what's irrational?
It never ends.
That which makes no sense.
That's kind of true.
Well,
it's funny because if I think about an irrational physics theory, for me, it's one that doesn't terminate in physical actors because it doesn't have an ending. You're never getting to any kind of ground, any floor, any foundation.
Because rational is sane.
It's
rational makes sense. Rational is predictable. Irrational is crazy.
Yeah, it's like a physical theory without structures is irrational because what are we talking about?
And they are moving along with the irrational as if that is a proper foundation for doing physics or math that is supposed to be rigid. So there's a contradiction in there.
I mean, the only argument could be that, yes, there's fractures in this formalism, but it is a formalism, and as long as it's applied consistently, that it can be used quite productive. I mean, obviously, the math that we have has been used productively for various technological implementations, architecture, rates, statistics, right? It's not completely useless.
No.
Nope.
No, it's great. It's great.
Okay.
It's great. Okay. The platonic solids are great if you are trying to define an area that is immediate in your space. If you're doing agriculture, the platonic solids are great for that. But when you're trying to deal with the universe, when you're trying to deal with space travel, when you're trying to go to places that are based upon curved realities, the platonic solids are never going to get you. You're never going to get there in a straight line. Even rockets, they don't sit up and say, okay, we're going to go just straight from here to the moon. They get up and they know that they have to deal with the curvature.
You know, it's the problem in informational space, too. We were hanging out with a bunch of AI researchers the other day. And do you know how these large language models work? They essentially create vectors of relationalness between related words and concepts, but they're in multiple dimensions. So they do the Pythagorean theorem, not with a squared plus b squared equals c squared, but with like a squared plus b squared plus c squared plus d squared. Like they have these huge arrays which are no longer in flat space anymore. They're in some hyperdimensional, hyperbolic reality, essentially.
But the moment they say square, they're going back to an imaginary structure that does not exist, because the square we know is an average of the space that actually is in motion. So anytime they talk about doing the square root of something, they're talking about a two-dimensional imaginary structure. It is imaginary. It's not real, because in order for something to be real, it has to be measurable. And in order for it to be measurable, it has to have 4 dimensions. It has to have the height, width, and depth, but we need our observational point to observe it. The 4th dimension is us, our time in looking at it and getting close to it. The observer is the 4th dimension, because the height, width, and depth don't mean nothing. 3 things don't hold up. You have to have 4 in order for it to have a contained center and an expandable outside. 3 sides will never provide a whole space. You need 4, and that's what Walter Russell led me to, because I was thinking 3 is the magic number, 3 is the magic number, and no, 3 doesn't get anywhere. It's 4. You need 4 things in order to measure something. So anytime they have two-dimensional things, they're talking about squaring something, they're still talking about imaginary things. And since nothing is squared and nothing is straight lines, everything is curved, and we're defining curved space, we need curved dimensional structures to define the curved space, because straight lines are irrational in curved space, and curved space is irrational in orthogonal or Cartesian space, in Euclidean space that is based on straight lines. So how are they using irrational things to define
infinite series
space?
usually, right? They'll do these infinite series of smaller and smaller and smaller and smaller bits in order to approximate the curvature.
So they take a circle.
This is, by the way, the renormalization problem for people who are listening. This is what we were talking about earlier.
They take a circle and they take an equilateral triangle, and they keep breaking down the circle into the equilateral triangle, and keep using smaller and smaller units, and go up a little bit and come down a little bit, go up a little bit and come down a little bit, and it's just an approximation.
Which seems to more or less work for most of the technological applications that people are using it for. And so I think that that's the reason that everybody's like, why would we change this? We can program computers with this. We can make computers think with this. We can do whatever we want with this.
But we can't get to Alpha Centauri with it.
And that's also the thing that Shiloh and I have come to, or when we're trying to justify the way that this book is being written, it's like, we've gotten to this point with the technology that we have and the knowledge that we have. But how much farther can we get unless we actually go back and look at these things and see if there's a better way of thinking?
It's like we're really good at electricity and magnetism for the things we use it for. We can make computers and stuff, but can we manipulate gravity yet?
Yeah, are they efficient?
Are they efficient even? Yeah. Have we maxed out the potentials available there? But gravity is a really interesting one too, because it's like, if you try to travel light years inside of an inertial system, you're screwed. Like, you're going to be waiting generations to get to these star systems. The only hope we have is a very sci-fi idea, but we have to be able to manipulate how these atoms are attracted to each other. You got to be able to disconnect from the gravitational web.
Well, let's look at gravity again. Another thing I presented on Joe Rogan was the simulator, with the same physics simulator that they use at Princeton, at Cambridge, at Oxford, same simulator they use at MIT, and we were able to rebuild the planet Saturn without gravity, without dark matter, without dark energy, just using linchpins and the vortices associated with them without any animation. And we were able to rebuild the planet Saturn, and showing that gravity is nothing but an effect of the electric force, and that planets are not built inside out. They are built from the expanding waves returning back. It's the universe that's creating all of these other shapes. It's the returning magnetic waves that are creating the pressure conditions that make us up. Because if everything expands out as a pebble, as a ripple and as a circle, as a sphere, then once the waves hit the edge of the system or the edge of the universe, they start bouncing back. But as they come back, they're greeted by more expanding waves. And when they get greeted by those expanding waves, that becomes the first contractions. And those contractions make up the physical form.
This, by the way, was essentially the wave theory of push gravity that was presented by Lorentz, from what I can understand. He also tried to use this model and I think to some degree of success. The problem came down to thermodynamics with these push gravities. They were concerned with how much heat would be generated if we're constantly being bombarded by these waves of pressure. They figured that the Earth would, I think I actually have the number here. The calculation shows the Earth's temperature would rise by 10 to the 26 degrees per second. And I don't know how to check the math on that personally, but the arguments against it were ultimately thermodynamic because, yeah, as a mechanism, it makes perfect sense. And I didn't get a chance to see oh, bless you.
I was trying to fight it.
The Saturn rebuild that you're talking about. I guess before we get to that, it might be useful to talk about the fundamental kernel of this model, which is the linchpin and the Tetreyen, right?
Tetreyen. It's called the Tetreyen, but I just called it Tetreyen now.
Tetreyen. All right, so the Tetreyen and the linchpin, and I feel like those didn't get defined well enough on...
You want to bring those other ones that we've already put together on?
Can you just explain to people the difference between the two? Because I feel like there's a lot of confusion about that.
Between what? The Tetreyen...
And the linchpin.
The linchpin. Well, let me grab... So the linchpin ultimately is the common factor. Like I use the term the constitution. It's an average. The linchpin is, and I'll call that clearly, the linchpin is an averaging of what takes place in the expansive and in the contractive. But the averaging is taking place according to consistent ratios. So this is a linchpin.
So we have 5 pentagons?
6 pentagons.
6 pentagons.
This is the linchpin, 6 pentagons, and it still represents the place where 4 bubbles are meeting.
These are bubbles of pressure in the ether.
Of interaction.
Of
expansion. These expanding bubbles.
Hold it up a little bit closer, yeah. And then closer to your face a little bit.
So this is a linchpin that becomes an average, but what's happening here in the center, if you were to look at that little center point right there, that is the same exact space right here.
And also...
which is the Tetreyen.
With this one as well, right?
Yep. So the Tetreyen being the contractive aspect of the universe.
Like the void, the low pressure.
The highest pressure system.
High pressure.
Because this is the highest pressure system because it's the first element that we can devise or can measure from what happens when those 4 bubbles meet. Then the expanded aspect of this from the this is a high pressure system. In its lowest pressure, the linchpin, the Tetreyen, now begins to take on 6 magnetic fields. So it's going from a masculine structure, being completely contractive, to now it is completely feminine as its basis. And the linchpin literally is the constitution between the macro of the magnetic field, of the feminine side, and the micro of the electric side, because this is the very small contractive, this is the expansive, And this becomes the communicator between the two. So it allows for interaction or change of particles between the small and the great, and it just keeps it's the tax collector, it's the money chain.
It's like the interface between these.
It's the money chain. And that's why I say it predicts all distribution of matter in how it aligns itself. So
if I can try to clarify this a little bit, because I talked with Chris a bunch to try to understand exactly, because you use Walter Russell's language, the expansive and contractive, and when I'm thinking about something like electricity and magnetism, it helps for me to start with an atom. And we haven't started with an atom here. We've started with an even smaller unit, and we should talk about that too. But he basically explained to me that if you start with something like hydrogen, you actually have, I believe, 4 of these bubbles. Is that correct? So if you have 4 of these bubbles, then there's a flow of that those interfaces. We would call them in normal physics or chemistry the electron shell. There's a flow of that etheric material across it. The directionality of that tells us the polar orientation of those bubbles. It has a pole to it, and we would call that the electric field in mainstream physics. The magnetism follows is the equatorial motion of that same etheric fiber around the equators. And so I want to make sure that I can translate between these, because that's what we're referring to when we talk about the expansive versus the contractive elements.
Well, the expansive is taking place here. You see these fields
equatorial
taking place on these planes. And that's what I was saying about being able to decouple or be able to travel. All of these planes have...
Oh, sorry, the expansion is electric field for you. So that's
expansion is the magnetic field.
Oh, it is. Okay,
because if magnetism... And let's clarify that. Mm-hmm. They use the term magnet as an attractor, the magnet. But if we look at the etymology of the word, to magnify means to make greater. To magnify means to multiply, to increase, to rarefy. It's rarefying, expanding things out. That's the work of radiation. That's not the work of gravitation. That's not the work of something attracting. It's pushing away. Magnetism is always pushing away. It's always repulsive. It's never an attractive thing, because the equator the solar wind coming off the sun never is an attractor. It's always pushing everything far away from it, the equator off the Earth.
Except at the poles, right?
At the poles, but that's not the equator. Mm-hmm, mm-hmm. At the poles, that's where the electricity comes into the sun, from the top and from the bottom, and it gets compressed in the center, and then it's forced. Now it can't go northeast, it can't be spinning to the right. Now when it gets to pushing off itself, it's forced to spin to the left, and it gets pushed out of the equator, from the Earth, from the sun, from our cells. Everything is expanding in that. So whereas electricity, it's the electricity between you and your husband that brings you all together. It's the alike nature. It's the positive things that are attractive. Positive things are attracted to each other.
That's the polar interactions, actually. Yeah, in the way that
the pole of the atom.
In mainstream, yeah, it's a polar interaction, right? Because when you're talking about electric field, you're talking about the polarity of the atom. Ultimately, at the end of the day. Although I'm not sure that everybody thinks about it that way.
But when they talk about, they say opposites attract. Where? Mm-hmm. Where in nature? You take water, you take hot water, and you take cold water. Which do they move in the same direction towards each other, or do they move in opposite directions from each other? You take hot air and you take cold air. Cold air drops down, hot air goes up. They are in opposition. They move away from each other. It's the positive. It's when two things are on the same plane, spinning in the same orientation, that they are attracted to each other.
Like two wires, for instance, the equatorial element, right? The magnetic field, as you would call it. I would just say that material that's in motion at the surface of those atoms is synergizing, because it is rotating in the same direction, and those wires will be brought together with some attractive force.
And so that our entire understanding about, and this is what Walter Russell was stressing, the terminology is wrong. It's confusing. It's like calling something black that's white. Or like when you look at our lights when we're driving on the street. I'll digress just for a second. You see the red light. The red light says stop. Well, that's not the way nature works. Red actually goes faster. Red is like, it speeds things up. It's expanding out. Blue or green, they say green is to go, but green or blue is more of a contractive and be still kind of moment.
You know who Mitch Hedberg is?
No.
He was this comedian back in the 90s, but he was like, bananas are the opposite of stoplights. He's like, yellow banana means go. He's like, green banana means hold on, wait a second, because it's not ripe yet. And he's like, red banana means where the fuck did you get that banana?
Don't eat it. So I'm saying a lot of our stuff, it's like we are living in bizarro world because they call a magnet an attractor when all of the work that a magnet does is expands out. A magnetism,
Pushing.
magnetism, it expands it and makes greater.
Well, I think that you have to look at it on the level of the atoms and the things that they're doing inside of the bar magnet in order to make sense of that, right? Because if you just look at the bar magnet, I mean, you take two bar magnets and they stick together. And so
In one direction.
In one direction and they pull apart in the other direction. So clearly there's something different going on. But if you look at the atoms that are within the magnet, then you start to realize that it, again, is this equatorial motion, which is this outward, I mean, to use your language, expansion. So scale matters.
And the thing that makes magnets stick together is the fact that they'll take the positive side and then the negative side comes over here, which allows for the flow to come in here. If you have two holes, if you have two water holes, and you stick them together, they're going to resist each other. So that's what that becomes their whole idea of, oh no, positive things are resistant to each other. They don't. But when they are aligned properly, then they move forward. And that's what happens with a bar magnet. One end has the positive charge, and then it has this feminine. The feminine is the negative.
It's the north-south by conventional.
Let the north be the male. Let the feminine be let the north or be the positive. Let the feminine be the negative. And guess what? Now when the positive comes into there, the male side come into there, now it's a proper flow. But it still gets back to the mating aspect of it. And it's not opposites are attracting each other because they do not attract. It's being aligned properly. It's the alignment, the flow of the electrical energy.
It's actually, I like to think of it, if you have a single atom and it's got its surface motion is turning in some way, if you define the orientation of that as the electric field, then you have a plus side and a minus side. And it makes sense that if you have two that are end on end, then all of a sudden, if there's turning in the same direction, the minus is facing the plus, and you have transmission of electric
But that
current.
becomes the male and the female.
Sure, yeah.
It's still a mating thing that we're looking at, and it's not opposites. That even their idea of a negatively charged system. How can something be negatively charged? To charge means to fill up.
It's just oriented
To
differently.
discharge means to pour out. So how can something be negatively charged when to charge is to fill and and how can you negatively charge something?
You just point all the atoms in one direction, opposite your
and pour
reference.
it out. You're basically discharging. And I believe electricity, magnetism is just devitalized electricity that because it's trying to get to a higher pressure condition. It's trying to get here, but there's other waves of other electrical potential trying to get here. So, I'll use this. So as it gets here, now the next wave comes and it's pushing it out to where now it doesn't have the strength or the pressure to maintain here because this system is less. And so now when it comes out here, it begins to spin centrifugally, whereas before it was spinning centripetally. We watch that with every kind of vorticular interaction, but
you got to really imagine the bubbles when you think about this stuff. You got to just picture in your brain the swirls, right, that are happening.
There's 4 big bubbles
to understand this model.
Which is why I like this model a lot, because it's the cross section of the spheres that would make it, and so you can see it a little bit more easily.
And it makes sense with that because now you can clearly see the 3 5s contracting, and they ultimately create a 6, which expands out. And that's what I was showing with those other pieces. With the when you put the 10 Arbrians together, you show the contraction, that everything contracts in 5ths and expands in 6s. Such a simple little walkthrough, but you have to rewrite all of physics to make application for it, and that's a tall order. But it's not a tall order if all mankind died today. Somebody would have to start over again, and I would rather they would start over with a truth instead of with an approximation.
Well, I think certainly starting with the assumption that some sort of physical actors are in motion are responsible for the things we call atoms, so that all of the physical phenomena would be a good step in the right direction.
And the idea that something like magnetism and electricity, which are clearly related to each other, because light is an electromagnetic wave, that it's 2 different motions of some similar substance.
Exactly.
And all of a sudden, instead of having all of these different phenomena, all these different waves that are reacting to each other or interacting with one another, you have at least a single substance that you begin with and try to model as best you can. I think that it's worth also mentioning that, one of the reasons that we departed from the ether was because the old models of the ether had atoms as being distinct from the ether.
Like little peas bobbing in a soup as opposed to being part of it.
Yeah, exactly. And that doesn't work out. But if you can reimagine the atoms as being like you said, a whirlpool or some kind of vortex or a motion of this substance, like it even
higher
fits
density, some sort of
some structure. Like we've been talking about this
yeah.
idea of the mixing the cold and the hot water, and you get a structure from the interaction of these 2 different types of motions. An interface. That's exactly right. And so, if you can imagine that the ether has some sort of crystalline motion to it.
What do you mean crystalline?
Just in the sense that it's organized. Like
it's predictable.
But it has to be crystalline. Like, remember, if A is equal to B and B is equal to C, then A is equal to C. And since everything in the universe works together and fit together, there is a commonality to it. And there's a common factor that it works with. Otherwise, it wouldn't. So what's taking place in a higher realm is actually taking place in the lower realm because it all fits together. It's unlike what the standard model says, that at the Planck level everything breaks down. No, it's even more organized because all of this is a result of those things. But their model is based on chaos. Their model is based on a dead system. Their model is based upon a purposeless system in comparison to where our model is based on a living system, a cooperative system, a collective, natural system. They, like we were talking earlier, they can't define. They say, well, noble gases don't behave the same way as they won't interact with regular matter, and they've never been able to say why. Why? What's the geometry of it? Have they ever defined the geometry of the elements in comparison to the geometry of a noble gas? And
this is something that's really tricky, right? Because I think that the chemists in general tend to understand that geometry is important. Like you talk all the time in biology about the stereo organization. Lock and key stuff, and also just does something fit somewhere? Are these
Shout out to the chemists. They're the most rational of all of the scientists.
Absolutely. And so we clearly know.
Until they start moving those electron bowling balls around.
But that is overlapping with physics, right? Because they go back to physics and they're like, okay, what is this thing? And the physicists are like, well, here's the equation that we have for it. This is how it acts. And then they're like, okay, fine. And honestly, like, this isn't a theoretical prediction that the chemists make. They're generally measuring the conduction of a chemical. They're studying chemical reactions and they're putting together tables of how easy they are or how difficult they are, and the various like electrical potentials that are inside of the molecules that lead a reaction to take place. They're experimentalists by nature. And yet there is this question of, well, why does this delta G fall out of this reaction? Like, why is there such a propensity for this reaction to happen that requires us to think about shapes and interactions? Because without that, it can't come down to anything except for magic, I think. So basically, if you don't have some kind of shape, if you don't have some kind of structure to the atom, then how can you possibly explain why one atom does one thing and another atom does another thing? You have to just depend on the fact of like, well, it's just that way.
Yeah.
And so if you can have an explanation that's like, well, no, the noble gases don't bond because of the way that they're shaped.
Which it's crazy because the standard explanation is because they have fully paired orbitals, and you're like, well, what does that mean? What does the Pauli exclusion principle actually mean? And it has no physical significance at the end of the day. There's these bowling ball things that are in opposite spin configurations, and you're like, well, what is spin? And they're like, well, it's just a quantity that has no physical significance. And you're like, but it seems to dictate how these things behave. So there must be something going on here.
And so the reason that they can't have spin be related to charge, I think, is because of the angular momentum of the electron.
Well, they haven't defined charge.
Well, they haven't defined,
physically.
But the reason that they can't say that spin is the motion of the electron is because the electron is a cloud, but it's a cloud of a point particle. And
of nothing.
Well, no, I think that it's like, this is where it gets really weird, because they're like, okay, so the electron's not really a bowling ball, it's an area of probability, but when they're talking about the relationship between spin and negative charge, they're taking the diameter of the electron and saying that it can't have so much angular momentum because it's so small, it would be going several orders of magnitude faster than the speed of light.
And Einstein says that's not allowed.
Exactly, but if instead of looking at the diameter of some hypothetical point particle, you were to say that, let's say the entire outer diameter of a hydrogen atom, the electron shell, is what's spinning, then I think that your angular momentum problem disappears, and you can say that the motion of that electron shell on the outside of the atom actually could be charge, because you're no longer violating the idea that the shell is spinning faster than the speed of light.
See, now here they're trying to define spin from all these spinners and all these other interactions, when when Newton basically, when he said that every action has an equal and opposite reaction, that is the cause of spin. When I was saying the greater the action, the greater the reaction, the greater the reaction, the greater resistance, the greater resistance, the greater the curvature, because everything has to spin off of that curvature. It all depends on the relationship of the action and the reaction. That's going to cause the change. That is the thing that results in spin. It's not some other emergent properties popping out that saying, oh, I'm going to be a spinner over here. That's made up shit.
It's like the dissipation of pressure in some sense.
Again, they're making up things. But like here, I'm going to try and explain why noble gases, again, will not interact with matter or regular matter. It comes down to their geometry. In my model, let's say this is the regular model. This is the regular atom. This is the atom. The linchpin would represent the proton.
Where all the bubbles converge.
Yeah, where those four bubbles meet. You put four of these together, they create, and this would be a magnetic effect because it's expanding in the center and causes a feminine. It has, because feminine expands. This has more of a magnetic interaction, and therefore, like, I can bond this with other linchpin, with other things that's made like it because it's similar. But if I were to take, in my model, pop that back up. In my model, in our model, whereas the linchpin, you get back together.
Destroying the universe.
You put it back together.
Oh my God.
We have the one right here still too. But if this is the normal matter, in comparison to a noble gas, having two caps, because all this is missing is a cap, a stem, and this has another cap, where this is just has one cap and one stem. This is like, what was the explanation of why it wouldn't move, why it wouldn't
Bond,
bond, because it had a completed, it had a,
spin matched electrons,
here
filled
is-
outer shell. Yeah.
well, this orbital down here has been filled, in a sense, because that is an orbital. But now if I put 3 of these together, where it takes 4 linchpins to come together to make one solid, one of these structures. It takes 4 linchpins to make that. Oops, I'm doing the same thing you did now.
This is a delicate operation, let me tell
Yeah,
you.
that's the only problem with using the magnetic ones, because they don't hold themselves as well as the other side of it will do. The difference between these, hold on, let's get this back into its linchpin form. 1, 2.
I think at the heart of this is you're talking about destructive motions at the end of the day versus constructive motions at the surfaces where these interactions occur.
Whereas here, I'm going to have to change and use some of these more similar pieces right here. I'll use these as a base, so it'll keep I'm going to create some stems now.
What did you say, Shai? Say that one more time.
I mean, I think at the heart of this, what we're talking about is the motion of that etheric fiber at these surfaces of these atoms is either constructive or destructive. And you get bonding when it can constructively work together, just like in the magnetism example, where these flows are in the same direction. And when you don't have that, you actually have a disruption, some sort of turbulent effect that means that you can't actually have that shared stream in one place.
Yes, 1, 2, 3. Here. This
Yeah.
will be the last one. And then I'll be able to make that point regarding the noble gases and why they're unable to interact. And I would love to, I love this idea of it. Oh, I needed a cap.
This takes me back to Legos as a kid.
I feel fully absorbed in this activity.
This is what we're all supposed to be doing. This is what makes us happy. But let me do this last one. So now, whereas before I took 4 of the linchpins like this to make this, took 4 of these to make this. With the noble gases, it only takes 3 of these structures, and they will also complete. I don't know, I did that on the wrong angle. I need to overlap them so that they're there. 1, 2. And then once the third one comes in, so now this structure, if you can look at the vortices, can you see this? If you look at these vortices on this,
The vortices are the axes of
these
the
points
linchpins.
that's sticking out. I'll say the
Protrusions.
protrusions. Yeah, let me use your linchpin since I just crashed mine. If you look at those in comparison to the normal matter, these having the 3.
The reactive matter.
Yeah, the reactive
A
matter.
little bit higher if you can.
Yeah, the reactive matter. Now you see why they can be around each other, but they cannot bond because of the edges of them. The geometry of them does not allow them to interact because these things are capped, whereas the linchpin, it does not have.
Linchpin is enclosed. Like the linchpin is actually a bonding structure.
It's a bonding structure, whereas the noble gases are permanent structures. And like in my model and what I was trying to explain and what Walter Russell explained, and me taking Walter Russell's model, Walter Russell explained that the noble gases sit on the edges of as the edges of a system. And when the noble gases are squeezing on each other between neon and helium, they're twisting on each other. They maximize into carbon. There's that's the maximum point of pressure in carbon. Then the secondary point is the boron and the beryllium. The other point is No.
You brought a periodic table with
got
you.
one right
Yeah, no,
there
it
if
was
you
the
wanna see.
boron. It's the boron and the nitrogen becomes a secondary bond. The beryllium and the oxygen is the third, and the fourth one is the lithium and the fluorine. Those are just iterations of pressure conditions between neon and helium squeezing on each other. These things squeezing and pushing on each other generate these smaller bubbles that we call the normal matter. But it doesn't have, like we said with the water, the smaller bubbles that don't have the same structure as it.
One thing that I think might confuse people too is that you're working under the impression that there are elements, there are, in the Greek sense, atoms that are smaller than hydrogen as well, right? So the fundamental of this harmonic system that you're proposing starts before the actual.
Yeah, there's like the alphanon, the gammanon, the other
alphanon,
pieces.
alphanon, betanon, gammanon, then helium, but
Then hydrogen?
Hydrogen behaves and sits in the same position as carbon. It's a plus and minus 4, the same way that carbon is a plus and minus 4, and carbon sits in the middle of the octave, the same way that silicon sits in the middle of the octave. They sit perfectly between the two noble gases, so therefore there must be a noble gas if hydrogen has the same spectral lines as carbon and behaves in the same way as carbon and silicon and cobalt, and all of them have a noble gas in front of it and noble gas before it. Then hydrogen should also, if it has the same spectral lines or same tone as carbon, then if A is equal to B and B is equal to C, then A is equal to C. So hydrogen needs a noble gas that it's pushing up against. So that's what Walter was talking about, even though we can't perceive it.
So we looked into this tonal relationship. We pulled up the NIST data for all of the spectral lines. There, by the way, are dozens of them for each one of these elements.
So theoretically, if you take something like hydrogen, it has an infinite number of spectral lines that are possible depending on how much energy you put into it. So the reason that it's difficult to look into a statement that says that these substances are harmonic versions of one another is because you can't figure out where to start. And so
in order to propose a harmonic relationship, you have to understand the fundamental. And if we don't know what the fundamental is, it's a difficult claim to evaluate.
Yeah, so basically
perhaps impossible.
What we both did is we went through, we collected the spectral lines for hydrogen, carbon, nitrogen, oxygen off of NIST. And you get this table. And you can pick, persistent lines, strong lines, whatever lines. And we picked the same ones from each kind, turned them, and you get them as angstroms off of NIST. Divided by 10, you get nanometers. And so nanometers, in order to get to frequency space, you have to divide the speed of light by the wavelength of your light. And then you get a frequency out of it. And then, if you're talking about harmonic relationships, those frequencies of the light spectra should be multiples of one another, right?
Integer multiples.
Right? So an octave relationship is 1, 2, 3, 4, 5, up to whatever.
Well,
1 technically isn't an octave, it's the identity. But yes.
Well, I was going to say you get the fifth and you get all these other intervals that emerge.
You do from the overtones.
Yeah.
But the thing is that I couldn't really find that relationship. There's definitely some lines that are multiples, whole number multiples of other lines. But it wasn't every single line in hydrogen is a whole number or gives a whole number multiple of that frequency in carbon. And I don't think that means that there is not a harmonic relationship.
What's the tone of carbon and what's the tone of hydrogen?
Well, so I can pull it
has technically infinite number of tones depending on how much energy.
But the base color,
the strong lines.
The base color that's generated on the spectral lines for hydrogen. What's the color of that in comparison?
I can tell you actually there's 15 lines that you look at, and when you look at these 15 or 16 different lines, you get just a collection of...
Yeah, read a couple of them if you got it open.
Yeah, hold on one second.
We
It's
made a little
loading.
spreadsheet yesterday.
We did. Our good little scientists put together a spreadsheet.
Yay.
Okay.
We actually called up this lady who studies this at Skidmore, and we found she hadn't. We needed to go one step further, so we put together this table.
So basically, this is over here on the left is you have hydrogen, and NIST gives you a bunch of data. So you have intensity, you have wavelength, you have the atom that it is the spectrum of, and where they pulled that.
They give you the prime resonant frequency off of it?
No, that's the
Nobody
thing. Like they don't
knows.
have
No,
one.
they do know. They do know. I actually, when
Is that
I
the ground
started,
state?
when I started this process, what made me go into trying to figure out, okay, I was like, well, let me define the prime resonant frequency of elements. I called up UCLA, I called up UC Berkeley, and I was like, hey, I wanted to talk to the people in the the chemistry lab. And I asked them, I was like, I'm trying to find what's the prime resonant frequency of the elements. They wouldn't give them to me.
Well, I don't think they know them. Like I think that
They have to know them.
Well, that's
Well, the lowest energy state is the fundamental, right?
but what is the slowest vibration of hydrogen that's possible? Like
Yeah,
even
well,
theoretically.
it's whatever would make hydrogen bond or break its bonds. That's those
Like the
are
ionization
states.
line?
Yes, that's the point. That's the prime resonant frequency, whatever is going to make it bond or break its bonds. They know what those are. They know those for all of the individual elements, but they're not sharing that information because I think they don't want you to be able to use frequency to generate and create any system because you don't need the element itself. All you need to do is create the condition.
I've wondered about that, and this is my most far out idea. But I'm like, if all of this is true, so this is prediction time. If this is so, I hate to use the word true because like whatever, but if this is so, if this is an accurate representation of nature, if there is truly an ether that's where it's vibrational or it's rotational or it's angular momentum is somehow the thing that gives rise to an element, as opposed to there being a thing that is the element. Like if it's an organizational structure, then you should be able to just take sound waves and create the thing.
You can.
Like you,
I don't think sound is the right word, but
Sound-
you should
no,
be able to
sound-
vibrate the substance.
electromagnetic.
No, sound waves, frequency. God said, let there be light, and there came to be light. And the first thing was the word. The word,
The vibration.
light, comes
Vibrations.
from
I'll go with
sound.
vibes.
Vibrations,
Vibes.
okay.
yeah,
Vibration
vibes, yeah. I go with vibration.
creates light.
So what does that mean though? Like for you? Because Shiloh, I'm sure that Shiloh has.
Well, I just think that sound, for all of the nerds out there, like sound is a particular kind of vibration that atoms do with one another.
Okay.
It requires a concert of atoms, essentially. Whereas light is some subatomic structure.
That only requires a concert of two atoms.
Yeah. And, there's other, like heat is a different kind of vibration of the atom. Right? There's all these different vibes. Like I'm down with saying everything is vibes for sure. That makes perfect sense to me, but they're different kinds of vibes.
It's all temperature. It's all tempo. It's all repetitive and according to a frequency. How often does this repetition take place? Everything comes back down to how often this change or this impulse takes place. How often is this wave created and what that does in moving something.
That's right.
That's what Tesla said. If you want to understand the universe, you got to think in terms of energy, waves, and frequency. Energy, waves, and frequency. And he didn't have the wave conjugations. He actually believed in the idea of straight lines. That was the thing where him and Walter Russell would fall out with because they were very good friends. And Nikola Tesla was like, you need to take all of your work and put it into a capsule, a time capsule, and keep it there for 1,000 years, and then bring it out, and in 1,000 years they'll be ready to understand what you're saying to them.
If only the FBI hadn't burned all his notes or
No,
whatever.
they didn't burn it.
No.
Donald Trump's uncle took all of that
no.
stuff. He took all of his stuff, and that was the mistake that
So it's sitting in a closet somewhere.
they've been working it out all these years. But that was the mistake Tesla made. He
It's
should
gotta
have
be his,
created a
like-
separate language. I created a separate. I was given a separate language in which I've written all of this stuff down. So you can take my stuff, but you're not going to know how it works because you don't know the language. And I keep all of my notes inside of that. So when are we going to, ooh.
We lost camera 4.
Camera 4 is dead. It's dead. It's done.
Oh,
No, we don't need
Is it?
camera 4.
you know, don't have no more charger. You just,
It's fine. It's like a wide shot.
Yeah, it's fine.
Don't worry about it.
you know, so we should,
Yeah, we've been at
should-
this for a while now. It's
Let's-
almost 5.
let's get into examining some of the pieces. I mean, are we going to look at them here, or are we going to?
Yeah, how do we want to close this down? We want to actually build some of these
You
structures
should be able
out.
to look at them. I think we should put.
We've already filmed a bunch of them, so we can overlay them too.
Did y'all?
We Matthew went through and he laid every piece out and he filmed it. And
Did
so,
you lay them out and build them?
No,
showing the symmetry.
They were
Some of
static.
them.
Some
Or
of
you did? Okay, well let's do. I think we should just so they understand what I was talking about, the grand unified supersymmetry associated.
Yeah,
with
let's show some.
which what they don't have with the platonic solid. Everything starts with the Tetreyen. This Tetreyen decays. The first decay that happens with the Tetreyen is now it puts on 2 magnetic fields. But those magnetic fields, they begin to align themselves and connect. Now, if you really look at this, this is the same flow that causes the twist behind a rudder. It's the same flow that causes a twist when you're urinating. When a man is urinating, you know, it's coming out and then you see it braids out and then it comes back in and it rolls. This is
the golden braid.
This is the golden braid. This is what's generated from the first decay of the Tetreyen. The second decay of the Tetreyen, it puts on now, it has 4 magnetic fields. And these fields begin to align themselves like this and arrange and creates this natural twist. And when they interact, again, they start re-putting things back together according to, I'll come up a little bit more, roll it out. This alignment, but also if I take 4 of these, I can build them into this. And this state of these 4, and this is what I was explaining about on Rogan, that if you look at this like this, these look like straight lines and it looks like a square based on that interaction, but if you really look at it, it's all curved. All of these things are curved spaces, but these overlap, and as you can see in this model, you'll see that these are 4 Tetreyens with the decay taking place. And what happens is these 4 Tetreyens combine with another 4 Tetreyens, and they generate the conditional space that creates the nature of this Huntian that will have only 6 magnetic fields and 6 magnetic poles, but 8 electric poles, which means that it has a greater electrical potential. So as these waves are overlapping each other, continuing out, then the next wave come in. But then what's interesting, the final decay is it decays down into 6 magnetic fields. And these 6 magnetic fields, now it's completely, it has a masculine center, but it's predominantly feminine. These things begin to align themselves in a similar pattern, 4 and 4, they can come together and create a magnetic or a feminine expression because it's expanding in the center, or they can be contractive and they're collapsing now the center, but what they end up creating, what these end up now creating are these structures. All a magnetic field that's building the lattice work that makes up what we would call the dark energy or the expansive part of the universe. But now here's the grand unified supersymmetry associated with it. You cannot put all of the platonic solids together and have them make any kind of sense, but all of these different pressure conditions, I can now take this system, I can align the other sides to it, let's bring it all the way up here and roll it one more time. I can now take what at the first stage of decay, the Tyronians.
Why do you call these decay, by the way?
I say decay because it's devitalization. They lose their electrical potential, and they lose their electrical potential, and then they become more feminine. So it's devitalized in the sense of not having the same strength of spinning to the right as tightly as it would like to.
Like there's less pressure that's holding it in place. And as you release the pressure, it becomes larger and occupies more space and so moves slower.
But all of these now create a grand unified supersymmetry that you do not get with any of the platonic solids or any of the models that they have. So when I call supersymmetry, I'm sorry, I should call it a grand unified supersymmetry because that's what this does, and it ends up defining everything. Now, that's just the first step from there. Now,
so do you think that this is like the structure of the ether then?
This is
like
the
this
etheric
flat
structure.
plane? Okay, so basically the etheric substance is organized.
That makes these up.
And so there's the original Tetreyen is at the interface of these 4 bubbles of the ether. And
Yep.
then as you press them together, the fluid gets either squeezed out or somehow modified in order to create this grid that you've made of the hyperbolic objects, would we
Yep,
say?
the petals come out.
The petals.
Remember what takes place here with the how a Huntian is generated.
In the hollow space.
In that
between
hollow
8
space from the 4
Tetreyens.
pressure, the 8 pressures of the 8 sitting there, they create this negative space. So therefore when this pressure condition changes, this thing disappears, so it seems like a massless particle. But as these things, another pressure condition, these now, if 2 Tetreyens join to the electric sides, these are all electric poles because they're concave. It's higher pressure. So now you'll have 2 Tetreyens on either side of the Huntian. I may want to get it different. Now we see how it behaves as a particle by itself, but when together it creates an entire waveform. And 5 of these will come, 20 of these will come together and make a natural dodecahedron, which I showed on Joe Rogan, or an entirely other field. But when these come together, now you've got a crystalline structure. So if I bring 5 of them together, I'll show you what that looks like. Then 20 of them come together. And this is what I was saying before. This is where I was saying everything contracts in fifths because we have 1, 2, 3, 4, 5 petals. 1, 2, 3, 4, 5. And another 1, 2, 3, 4, 5. 3 sets of 5s contracting, but you have 6 petals expanding from the center. 1, 2, 3, 4, 5, 6. So everything contracts in 3 sets of 5s, and then they expand in 6s. Expansion comes from the center. But then I put 2 of these together, they make a natural icosahedron. So now when you have 10 of them together, they began to predict every potential wave field. And every one of these points is called a harmonic node. All of these harmonic nodes is where matter occurs. So it's able to predict all distribution of matter and tell any interaction that's going to happen. Or I can take 4 of these, and now they create this standing wave. And all of these are things that we've seen in nature. We've seen galaxies and everything behave according to these. We've seen things in the universe that behave like this. The platonic solids don't generate this. The standard model doesn't explain this without having to create unnecessary pieces, unnecessary things. So it's hands down, and this is just me defining the electric field. This becomes part of the magnetic field, which I would believe would be the dark energy causing the expansion of it. It's just happening at a higher pace, at a higher pressure condition that we can't perceive to a point. And so this is what I wanted them to evaluate. This looks like what we consider a photon to be. It's the aerodynamics associated with it. It's not something that should be ignored, but then these also decay. And their decay becomes like this. Everything slows down, everything goes through its transition. Now, if the standard model has a better description of all of these things than what we're doing, then I'm all for it. But as far as I understand, the standard model, the string theory, none of those things define what we've been able to do right here. None of them get to the linchpin where you can have 4 linchpins come together here, and then these 4 will bond here, but they're still creating the same tetrahedral structure. Same tetrahedral structure, or 5 linchpins together. Like this is the feminine side, like I said, because the feminine is always expanding. Whereas this is the contractive side, this is the masculine side. It's still a tetrahedron, but you see the dodecahedron has now been collapsed. So that's why we call it electricity, because electricity is now giving off energy. It's higher pressure. But these will come together and keep bonding and making these predictable crystalline structures that will keep growing. Will you bring me the 5 plane that's the same grade like that? So this is an electric field, an electric system right now. But a higher contractive electric system, like at the center of the Earth or at the center of the sun, it will get to a point where it will plane out. But these planes, look at what they generate. And these structures just keep growing and expanding. But they will also they will also continue to make the same same bonds and keep growing. The crystallization never, ever stops as long as you follow the geometry and follow the patterns. That's what I'm talking about. That's the prowess that if they have a better model than what I have, then hey, I will gladly put these things and retire them. But as far as I know, it's game over. It's drop the mic and, give me my Nobel Prizes or get out the business.
I thought we established that Nobel Prizes don't matter.
I know. They don't. But if people are
But it'd
getting
be
Nobel
nice,
Prizes for nothing,
It is $1 million.
yeah, but I make $1 million in 2 days, so that don't mean jack to me.
We're in the wrong.
That's my rate.
We're in the wrong business.
But that's what I'm saying. So I don't want anything from it but to be able to benefit the world. And now we can utilize these things to predict all energy. We can utilize these things to re-engineer or the materials engineering. Because before, now that we can model what hydrogen does or how hydrogen bonds and interacts, now we can manipulate that. Whereas before, they've never been able to do that.
And ultimately, that's the goal, right? Like a theory that unseats the one that we have right now is one that can account for that and actually make a prediction for what technology we can achieve.
I call this the mirror all shapes, because I call the Tetreyen the Tetreyen, the masculine. And since my wife is the feminine, I call these the mirror all shapes. So she represents that side of it. But if I collapse these, I'm able to now stack them. And they generate this space. But what's fascinating about this space, if I now take 6 of these, watch what they're able to do. 1 second. 1, 2, 3, and we have our 4th system come on, and you can see this looks like what takes place with a star and all of these opposing vortices that makes sense and continues to grow out from it. This is what the magnetism or the magnetic or the feminine side is able to do and grow out. They don't have this in the standard model. This we call this the world engine. Me and my wife, we call this the world engine. But this is the dynamics of what's taking place on a star. Here, go on ahead, you guys. Look at it yourself. That's the all shape. And I make 6 of them into like a turbine. And this would work like a wonderful turbine because it's smaller here, it keeps falling, grabbing. How do you argue against this or just walk out or just piss off on it? Or if I take 5 of the linchpins, 5 of the mirrored all shapes and put them together, they start creating these structures that here's 3 sets of 5 that behaves the same way that 3 sets of 5, 1, 2, 3. It always repeats itself. This system is self-referencing and it's self-repetitive. So it's I don't get the resistance.
We've just gone through and looked at the way that all of these structures fit together. And I think
some of them. It's not all of them. It's just I've tried to bring just enough so that it wouldn't overwhelm and confuse.
But basically what we've come down to is that there is most likely an etheric substance that fills the universe. The etheric structure, or the etheric substance must have a structure. and you have proposed a structure for said etheric substance, which can tile and combine in various ways due to expansive and contractive properties that allow it to change shape in order to create these different
Composite entities.
I like that. And so I think that somebody who's watching this or somebody who studies conventional physics can look at it and dismiss it out of hand just because it doesn't follow the language that one would use for a conventional physics presentation, or it's not within the frame that they're used to thinking about the universe. But I think that there's something really, really valuable about A, the project of trying to understand what the structure is, and B, a presentation that lays it out and forces you to think about whether or not that presentation makes sense or is the right one. Because as long as we don't have people in the world that are working on this project, we will forever be stuck in a place where at the basement of reality is mathematics. And I do not understand the intricate details of the project well enough to say this is 100% so or this is not 100% so, but I think that the value is that it gives us a starting point for thinking.
When you examine the coincidence of this grand unified supersymmetry, because it doesn't just tile horizontally, it tiles vertically, it tiles volumetrically, and
Twist tiling, chirality.
It all has chirality, all of these things. So when you are faced with all of hundreds of coincidences that seem to tell a story, then it should push someone to do a greater dive in, a greater evaluation of these things, because it hits a lot of marks. It marks off a lot of the checkpoints. So that's all I'm looking for, is to hopefully, get a university that cares about the future, that cares about, what we're learning in engineering, and would like to examine these things so we can put it to bed once and for all. And that university that would work with me, I would give them an exclusive license to work with me, to where that any other university that wanted to come and discuss these things, because all of these things are patented, those universities are going to have to come and get a license from that university. So I'm proposing, in the amount of technology that we can build from it, the relationship that Hewlett-Packard had with Stanford, that's nothing compared to what an entirely new set of fundamentals, if proven to be true and put into application, along with all of the other patents that I've worked on, or the other innovations I've done regarding the, flight, regarding lighting, regarding nuclear waste, regarding, all of the things that I've done. I would be willing to work with that university and make that the wealthiest university on the planet, and the smartest university. That's what I would propose for even a small university or a large one. But first come, serve. First come, first serve. Everybody else is going to have to come and get a license from that university afterwards.
And in some way, I like this because it's a very broad prediction. But basically what you're saying is that understanding the universe starting from this geometry gives you the ability to create technologies that nobody else has made yet.
Yes.
And if that's the case, then there's nothing to argue with.
No. And it's like I said, we have our prediction models that work, and that's worked consistently, and would be more than willing to explore some of those things, and willing to share in what comes from that. So it's, take off the resistance and let's grow.
I love that.
There's a guy who has a YouTube channel named Alexander Unzicker. Do you know who he is by any chance?
No.
He did a really fascinating series about dislocations in lattices being used to show particle symmetry. And I think that one of the reasons that he wasn't totally satisfied with that kind of theorizing was because the unit that he was using was a cube, and he was trying to tessellate the cubes into these different arrangements. And so I wonder if some of your ideas wouldn't find a home in that lattice defect idea, because this was something that was studied back in the 19th and 20th centuries when they were trying to make sense of the ether and the structure of it. But they didn't, of course, again, they were trying to use the straight line cubes to make these different chiralities happen, and it was problematic for that reason. But it's some really compelling stuff, and he's got a cool series over on YouTube about it, and I think he's written some papers as well.
You guys reach out to him, talk to him if you guys know him or anything. I'm kind of done with doing podcasts. I wanted to do this because I wanted to give the audience an opportunity to actually see the pieces and all of that. But after this, I'm done on going out and trying to propagate and talk about it. Now it's just getting into the lab, working and building the linchpins out, building on our propulsion system, building on the neutrino system. It's time for to do the work. It's enough talking. Whoever was going to listen is going to listen. And if you have ears, hear. If you got eyes, see. But if you don't, then you won't hear this anyway. But you will not be a part of the future.
How do you imagine, if people are interested in these ideas, how can they contribute or collaborate? Is there a space that you can imagine that happening in?
Yeah, I mean, you can easily, my whole thing is like I said, this didn't come from me, it came through me, and I'm supposed to share it. I've written a book, 1 × 1 = 2, it's under tcotlc.com, so anyone can look that up. Or you can go to Terry's Linchpins, and that's TERRYS, Linchpins, LYNCHPINS.com. And you can go and have our site that has a lot of this information, a knowledge base, and you can do a really big, deep dive. You want to leave a message and a comment, I will. My team will be glad to reach out and hear and talk about it. And anyone that really wants to be a part of the future, come along and let's do something.
Yeah, and we're of course on Discord, Facebook. Chris, one of your collaborators, is always hanging around. He's happy to answer people's questions.
Yes,
too.
Chris Seeley.
Yeah. So I don't know. Thanks for making this happen, man. It's been wild exploring your mind for the last few days.
Exploring your minds and your hearts. You guys are genuine and earnest, and you care about this stuff. The real scientists.
Trying to make sense of things, That's
demystify science.
Indeed. Yeah, it's been really good. Thank you.
Thank you, guys.
Bye, everybody.
Bye, everybody.
Thank you, brother.